Welcome back. And now let's see how we can get the local explanations or generate the feature importance data for individual records. For that, let me first create a small data set of just 5 records from the x_test. And I'm going to call it x_explain equals to x_test and within square brackets 0:5. So we will generate the local feature importance data for these 5 records. Now, to get the local explanations, we are going to use the same object of tabular explainer, but the method will now be explain_local. And let me collect that explanation in a variable called local_explanation equals to tab_explainer dot explain_local followed by 2 parentheses. And then provide these 5 records which we have in x_explain inside the parentheses. So this will generate the local feature importance data for these 5 records. So let me first select these lines and execute them so that we can see what this object of local explanations have. It went fine, and now let's open it from the variable explorer. And if you scroll down a bit, you will see these get methods, and we are going to use these two of local name and local values. So if we use this get ranked local names, we will get the feature names, and the values will give us the corresponding feature importance values. So let's code the feature names as local_features equals to the object of local_explanation dot get_ranked_local_names with 2 parentheses. Then let's get the local importance as local_importance equals to local_explanation dot get_ranked_local_values with 2 parentheses. Select and execute these lines, and then we will see what is retrieved by these 2 methods. So first, let me open the local_features. And as you will see, it is a list with these 2 records. The first one is for the negative label, or we can say for not greater than 50k label. And the second one with index of 1 is for greater than 50k. So irrespective of whatever has been the predictions, it will tell us the feature importance for those predictions. So let me open the first list, and this list is for the x_explain, or the 5 records that we have provided for local explanations. Then that also has another list which has the actual feature names ranked as per their importance values. So let me just arrange them nicely so that we know the path that we need to travel to get to the feature names and their values. So the first list has a list of classes that we know. Then the second represents the records, and the third finally has the names. That simply means if we need to access all of these, we will have to run 3 for loops inside each other. Let me code it, and then things will be a bit more clear. And for now, I'm simply going to paste my existing code to save some time. It's a pretty simple code. It just looks a bit complex because of all these loops and print statement inside that. So let's break it down line by line. The first or the outermost loop is on labels. And here we have 2, but there can be multiple labels in case of multi-class classification. So for the first iteration, when I is 0, labels will get this first list with index of 0. Then we run another loop on this list of labels for 5 records. So during the first iteration of this second for loop, we will pick up this list of feature names and then run a third loop on this feature names list and print these names using this index of k. But remember, these are just feature names. The feature importance values are stored in this variable of local importance. And we need to travel the same path of I, j, and k indices to get the respective values. And that's why you see these 3 square brackets. And finally, we print that over here in the end. All the \t is just for indenting them nicely while printing it. Then we also have this if block where we check whether the label we are considering is the same as the predicted value for this record or not. Because it gives the feature importances for all the records and for both the classes or labels. But we are interested in the predicted one, and that's why we have this condition here. Great. And now let me select these lines and hit Ctrl+Enter to execute them, and then things will be absolutely clear. It should be done pretty quickly. And now, in the interest of time, please allow me to explain these findings in the next lecture. See you soon, and thanks for watching. Welcome back. Now, before I adjust these frames and show you the output, let me open the x_explain and y_predict. So out of these first 5 records, only the 4th one has been predicted to have income greater than 50k, while the first 3 and this 5th one has the income less than 50k. Okay, let me close the y_predict only because we will need the x_explain when we do the analysis of the explanations. Also here, let me adjust the console frame so that we can view the maximum of these prints. And also scroll up a bit because we have printed quite a few lines here. Great. So let's see which features had the highest impact while predicting this first record as negative or not greater than 50k. So the topmost positive impact was by education of high school grads, then number of hours per week and the working class of private. But if you scroll down to the end of this list, you will see that marital status of married, age, and never married had the maximum negative impact. And it simply means these 3 features were trying to predict it as greater than, while the other 3 were trying to predict it as not greater than. So higher the age, there is a higher chance that the person would be classified under the greater than 50k category. Then the working hours per week is a normal one of 40 hours, not too high or not too low. but in this case, our algorithm has used it to classify the record in not greater than class. Then if you scroll towards the right to see this education high school grad feature, you will see that it is 1, which has played the major role in deciding that the person earned less than 50K. Now let me go to the column of marital status married. And here it is. And as you can see, this person had the marital status as married. Based on the fact that it had maximum negative impact on this prediction, we can say that if the person is married, there is a higher chance of he or she earning more than 50K. So, if I have to conclude this local or record level analysis, I may say that despite this person being married and has higher age, he or she has been classified under a not greater than class because of their educational level and number of working hours. Alright? And then even for this second record, the person is not married. Scroll towards the left and you will see the number of working hours per week is just 30. And once again, the educational level is of high school grad. Great. And before we conclude our lecture, let's see the lone survivor or the fourth record which was classified to have income greater than 50K. So, the status of married, education of masters and the hours per week had the maximum positive impact in predicting this record as positive. And rightly so. If you see here, he has the status as married. Then let me go to the left and you will see that he has master's degree. Hours per week as 60, which is on a very higher side. Even the age of 43 means he has good amount of experience in his field. So with all the positive indicators, our algorithm correctly classified it under positive class. Alright? Great. And I hope now you understand how we can get, analyze, and explain the local feature importances for any and every observation. But so far, this was all done on our local machine. In the next couple of lectures, let's see how to do this using a compute cluster on Azure, as well as how to upload the explanations to our workspace. As always, it's a pleasure to teach you Azure Machine Learning. Thanks for watching and see you soon on the other side. Welcome back, and today let's see how to create and upload the model explanations to the Azure workspace. So I have this script run job which is very similar to the previous one we saw for Hyperdrive or any other script job. There are some minor changes that I have done here. Instead of defaults, it's the adult income dataset, which is same as what we used in the previous lectures. Then while creating the environment, I have added this additional pip package of Azure ML Interpret. And these are the only minor changes to this script over here. Then in the script, it has the same usual steps of importing the run, getting the run context, accessing the workspace, and then parsing the parameters. Then under do your stuff, we first load the dataset using the raw data. After that, these are exact same steps we did in the previous lecture on explanations. Then after getting the score, we log it as accuracy, import the tabular explainer, create the features and classes, create the tab explainer object, and create the explanation object. Hope there is no problem whatsoever in understanding this. Now, in order to upload these explanations to the Azure ML workspace, we need to create an explanation client object. For that, let me import another class from Azure ML Interpret as from Azure ML dot interpret import explanation client with E and C capital. And first of all, let me select and run just this particular line so that we can see the description of this explanation client. Let me open it. And we don't have a great description here apart from the fact that it defines the client to upload or download the explanations. But what I'm interested in is showing this method of from run. So we can use the current run object and then create an explanation client object for it using this method. And we simply need to provide the run object as an input parameter. Alright? Then we also have this method of upload model explanation that we are going to use in this lecture. And as the name suggests, it uploads the model explanation information to the run history. If you remember, there was a tab called explanation in every run. So when we upload these model explanations to the run history, we should be able to see it under that tab. As part of this method, we can also specify this parameter called top_k. It simply means how many top features we want to upload as part of this method. If we don't specify anything, it will upload all the feature importances. Okay? Then let me scroll down to the end, and this parameter of visualization points specify how many observations we can upload with their feature importances. The upper limit is set to 20K, and that is not a problem for us because we only have 2000 records here. I hope so far everything is clear over here. Let me close this, and now let's create a client object of this class using the from run method. So that will be explain_client equals to the class of explanation client dot from_run and within the parenthesis new_run, which is our run object. Next, let's upload the explanations as explain_client dot upload_model_explanation and within the parenthesis this object of explanation that we have created over here. You can also add a comment if you want as a comment after a comma equals to my first explanations. You can give anything you want. More appropriate would be tabular explanation or something of that sort that provides some meaningful information when you open it in the studio. And that is true if you are trying to upload multiple such different types of explanations. And finally, we need to provide new run or new underscore run dot complete with 2 parentheses. That's it. Save this file, and now we are ready to run this job. So come back to the job and select all the lines and execute them. It will start accessing the workspace, allocate the environment, provision the compute cluster, and finally our run will begin. So it is going to take some time, so let me end this lecture here and come back to you once the run is complete. As always, thank you so much for watching. Welcome back, and now let's see how this explanation looks like in the studio. So go to the Experiments tab, then go to this Run 1 of our experiment, click on this Explanations tab, and here you will see this explanation ID for the explanations that we have uploaded. Click on the explanation ID, and I'm not very fond of this Model Performance tab inside this. It's just a box plot giving distribution of the predicted values. Maybe Azure will add some better plots there later on. So first, let me go to the Dataset Explorer, and click on this individual data point instead of the aggregate plots. Now, this shows you a scatter plot of various features and also marks the predicted label with a different color. And such scatter plots can be very informative. As you can see here, majority of these orange dots are found above this line of 30, which means most of the adults earning more than 50K are above the age of 30 years. Remember, this data was compiled in 1994, and wages during that time were not as high as what we see today. And if I'm not mistaken, the average income of an American adult was around 25,000 per annum at that time. Then if you want to draw a scatter plot of some other feature, you can simply click on the age and select a particular feature from this drop-down. So let me select the hours per week and click on select. And once again, this clearly shows us that usually the people working for more than 40 hours per week had a higher chance of earning more than 50K. If you want to see it very clearly, let's click on index here and instead of index, choose the predicted Y as the value on x-axis. And there you go. Now things are pretty much clear here. While the not greater had the data points spread over the entire range of working hours, the greater than 50K data clearly shows that more than 90% of them work for more than 40 hours. Again, going back to the history, during the early 90s, if someone has a full-time job, he or she would usually work for 44 hours or more. And maybe that's an indication that people putting in lesser hours may be having some sort of part-time job. Similarly, you can check various plots over here and create your own analysis. For now, let's move on to the aggregate feature importance. And by default, it shows us the top 4 features. And we know them as marital status, age, education of high school grad, and the number of hours per week. If you want to see more, you can simply drag this slider and adjust your viewing area. Great. Then come down a bit, and we have this area for viewing the dependence plot. Let me select the feature of age from here, and it will create this dependence plot of the feature importance and the age. So we have the age on the x-axis and the feature importance of age when it predicted it as not greater than 50K on the y-axis. Now, because this is for the negative class, you will see that it has maximum impact when the person is younger, almost touching 0.3. Then as the age increases, around 35 or 38 over here, it has almost negligible impact. Then once again, as the age increases, the impact is negative, but that is considering the not greater than class. For the positive level, this graph would be an increasing graph. Also, this graph stands very firm even on the grounds of common sense. And the reason I say that is because if you see some of these records, which are around 50 or in early 50s, they have the maximum impact there, which means the salaries will be greater than 50K if the person is around early 50s. That could be because the person is about to retire and is at his or her peak income level. Okay? Then the same thing can be observed if you see the dependence plot for hours per week. So as the number of hours increase, the impact on not greater than class goes in the negative territory. And the last plot that I want to show is that of marital status as married. This clearly shows that when the value of this feature is 0, the feature importance for not greater is much higher and in positive territory, whereas the impact is completely opposite when the person is married. Great. And now let me quickly show you the individual feature importance tab. Here you will see the scatter plot of any of your feature on the y-axis and the probability of greater than or not. Then if you want to see the individual feature importances for any of these data points, you can simply click on that point. And if you scroll down a bit, it will show you the local feature importance for that data point. You can select more than one data point by clicking on some other data point over here and then see the comparison of the feature importances. This is particularly useful when you have some small number of visualization points. Otherwise, this plot could be a very thick plot and you may not be able to identify certain visualization points. But I'm sure now you know how to create the explanations, upload them to the workspace, and even analyze them at a global level, as well as at the local data point level. As always, it's a pleasure to teach you Azure Machine Learning. Thanks for watching. Hello and welcome. And in this last lecture under Explainer, let's see how to download the model explanations from the workspace. And it is sometimes necessary to download the explanation because it's possible that the experiment run has been created either by Studio or even by someone else sitting at a remote location, and you may want to access just the explanations for the run. This is pretty easy, and because we have done almost all the steps earlier, I am simply going to walk you through it. So I have imported the explanation client and the workspace classes over here. Then as usual, we have the object created from the config file. And now I'm not sure whether we have seen this before, but using the get_run method, we can get any run information as a run object by specifying its run ID. And make sure you copy and paste your run ID over here. This line over here will then create the new run object in our Spider session. And then we also create the explain client object using this explanation client class and the from_run method. And this is precisely the reason we needed this run object. Alright? Then, similar to uploading the explanation using this explain client, we have the download model explanation method, which will create the explanation object. And this downloaded explanation is the same type of object that we created earlier using the tabular explainer. And that means we can use this method of get feature importance dict and create the same dictionary that we created earlier. So let me simply select all the lines and execute it using Ctrl+Enter. Give it a few seconds and it should be fine. It has completed successfully, and let me now open the feature importances dictionary. And there you go. We now have all the features as the key and their importances as the values of this dictionary. Great. And if you want to download it in just one go and don't want to manually write this script, you should do that in the configuration job after the entire processing has been completed. Great. And with that, we have completed another exam objective of using the model explainers to interpret the model. And initially, it may appear just two simple sub-objectives. But these concepts of interpret community, Shapley values, and the local versus global explanations are pretty new to the aspiring data scientists and in some cases even to the experienced ones. And that's why I thought of spending some little bit more time over here. I hope you have liked it and enjoyed it as much as I enjoyed teaching it. Once again, thank you so much for joining me here and have fun. Then we also need to provide the name of the script that we need to run whenever a request is made to this service. And that also means we need to create that entry script to retrieve the models as well as these transformations that we have saved. And finally, with all these artifacts or components, we then deploy the model to the server and we can then consume it as a service. We are going to see each of these steps in detail, and I am pretty sure you will be able to deploy your own production-grade services once you complete this section. So let's get started, and thanks for watching. Welcome back. So as part of the deployment, we first need to save the transformations and trained model objects. I just created this new experiment in the designer and ran it successfully. And then if you remember, when we wanted to create a inference pipeline or the web service, it will then change the structure in this particular manner. So what was clean missing data module would now be converted into this clean missing data transformation. Same thing happened with the data normalization as well. And the trained model is now another transformation. Now, why do you think we need to save these transformations and then apply them during production? Well, we ran these modules using the training or sample data. As part of that, we provided certain rules such as which columns to clean, which cleaning mode to apply, and then during the run, we calculated the values of those cleaning modes. So things such as mean, mode, median, or any other constant using which we are replacing the missing values were created during the experiment run. All of these are stored in this data transformation. And when we want to predict during the production run, we should be applying what we learned during the training. And that's why we apply the same transformation on the production data as well. And same thing happened with normalized data also. This transformation has the answers to these questions of which columns have been selected for normalization, which normalization method such as min-max or z-score or any such should be applied. Then it also has various values such as minimum, maximum, standard deviation, and so on that were created and stored during the experiment run. Now, similarly, the trained model has various weights or coefficients of the independent features or any constants that's part of the derived formula for prediction. I hope now you understand why we need to save these transformations. In this case, it was handled by the AzureML designer. But then the question is, how do we save it in Python? Because when we use the AzureML SDK, these are Python objects and Python has a certain way of storing them. Well, if we want to make use of these objects on some other machine, we need to save them in a serialized or also known as the binary format. For some of you, this could be a completely new term. So let's try to understand this model or object serialization process. So typically, you will have some objects in your program which will have some attributes and functions. As part of serialization, we can store them in a binary format and then either save them for later use, transmit them on different machines or on cloud server, and then we can create a similar clone of that object by means of deserialization process. And in case you want a standard definition, this is what is there on the Wikipedia for object serialization. So it is a process of translating the object state into a format that can be stored in a bits and bytes format or even transmit this stored object. I know it can get boring at times and a strictly technical language can really put you to sleep and maybe even difficult to understand. So let me apply the same old KISS formula of keep it simple stupid. So let's try to understand the object serialization using the example of milk. And I don't think there can be any other common example than milk. And by now you know I love simplifying complex stuff. Anyway, let's say you are going for hiking or camping to a very remote location. And there you need milk for making tea or coffee. Now, if you want to take milk bottle or the milk pouch with you, it's a problem. Because firstly, it will be difficult to carry so much milk in case you are going there for 4 or 5 days. Then another problem is it is perishable, which means it may go bad the very next day. So what do we do then? Well, we can always carry the milk powder. It can be easily carried and it lasts much longer. So what we basically did here was translated the liquid state of the object called milk into the milk powder so that we could store and carry it along. And this is nothing but serialization. Then when we want some milk, we simply add some water to it. Remember, we have to add water and a fixed amount of water to get the required consistency of the milk. We can't add edible oil. It has to be water. So some kind of standard process has to be followed to create the clone of this milk from the serialized object of milk. And this is nothing but the process of deserialization. Isn't it simple now? Pause the video and read the Wikipedia definition once again. Now it will make much more sense. So just to summarize it, as part of serialization, we change the format and state of the object to the binary format. And then when we want to use it somewhere else, we simply create the clone of the object by means of deserialization. Alright? Great. And for Python, we have multiple libraries and modules such as joblib, pickle, and dill to serialize the object. I'm not going to go into the details of each of these. For now, as part of this deployment, we are going to use the joblib. It's pretty simple to use it, and let's do some hands-on of a couple of methods of this module, and then things will be absolutely clear. So see you in the next one, and thanks for watching. Alright, so let me select all these lines now and hit Ctrl plus Enter to execute it. This should be done in a flash, and very soon you will have the scaled values in data 1. If you want, you can visualize it. I will do it a little later. So first, let's see how to load or deserialize this object. So in this file, I have coded few simple lines of reading the data and then getting the numerical column names. I have also imported the joblib, and then we have this path of the object file over here. Now, by coding in this new file, I'm simply trying to demonstrate the fact that we can load the pkl file from anywhere and create the clone. Okay, so now let's load this pkl file in a variable as sc equals to the module of joblib dot load, and inside the parenthesis, simply provide the path to the pkl file. And this will create the clone of the scalar object with all its attributes in this sc. Great. And now let's transform this data2 data frame using this sc scalar clone. So that will be data2 and within square brackets columns where we have all the numerical column names, and that is equal to sc dot transform, and within parenthesis once again data2 with columns inside the square brackets. And as you must have noticed by now, we didn't have to import the min-max scalar. We didn't even create the object of it, and we didn't have to even fit the data. This object of sc already got all of that information from this pickled object. And if what we are saying is true, then this line should create the exact same data transformation as we created in the previous program. So let me simply select all the lines here and execute them. It should be pretty fast. And now let's open the data1 and data2 from the variable explorer. And if you place them side by side, you will see the exact same data in this column of age. Great, and I hope that now clears and demonstrates the concept of serialization as well as deserialization of the object. Remember, the data1 age is transformed using the normal object, which means by importing the module, then creating the object, and then applying the fit and transform method. Whereas for data2, we deserialize that object and then applied the transformed method. And the fact that we got the same result proves the serialization and deserialization. Great. And with that covered, now let's see how to handle the dummy variable transformation in the production. That is one very important and tricky concept when we are deploying our models in the production. So see you soon on the other side, and thank you so much for watching. Hello and welcome. So we now know what are data transformations, what is object serialization, and we also saw that using the joblib's dump and the load functions. Also, the joblib or any such library will accept the object as an input. And this input usually comes from these fit methods in case of machine learning. But the problem comes when we are dealing with the dummy variable creation, or also known as one-hot encoding. The get_dummies is actually a function and not the method of a class. So it is not changing the state of any object. In fact, it creates a new object of data frame. And that means it is of no use in production because it will always create a new object. And that may be different than what we used for training the model. And in case you find it confusing, let me explain using an example. So let's say we have this input dataset with just the name, income, and education columns. And when we apply the get_dummies function on it, we get a new hot encoded dataset with these new columns. For now, I'm treating the name as the categorical column just for the example purpose, even though it acts like an ID column. So this new data set now has 7 columns. And then we perform model training and create the trained model from this dataset. No problem there whatsoever. But now, during production. Let's say it's a real-time inference service and we get just this one record as the input. Now, what do you think will happen? Because practically that's how things are going to happen. So the actual production run will have just one or maybe a small set of the training data. Now, when we apply the get_dummies on this dataset, we get the new dataset like this. Because here, name has only one category of Jitesh and education also has just one category of grad. There is nothing wrong in performing the get_dummies here. It's just the way data is provided to that function. But the problem is, if we pass this dataset to our trained model, it will give us an error that the number of features do not match or we have some missing features. And that means before submitting this dataset to the trained model, we need to add the columns which are not part of this data frame and also add them in the same sequence as the trained data. And of course, they will have values as 0, but they need to be present for the model to predict. Alright? And I hope this issue and its solution is clear, at least at conceptual level. Great. Then we have a second issue. Now, what if the input during the production run has a category that was not present in the training dataset? Something like this high school in the education column. In that case, our data frame will look something like this after the get_dummies. And when we add the missing columns from this training data frame, we will have 8 columns instead of 7. Again, that's a problem. And we should get rid of any such column. So in summary, what we need to do is during training, first extract these column names using which we train the model. And the extraction needs to be in an object format so that we can serialize it and pass it on to the production environment. You can even save them in some sort of CSV file and even read that file during the production. Even that is perfectly fine. Then during the production run, we need to add the missing columns if we have any such missing columns there. And almost all the times you will have them. Also, if there is a new column, then we need to handle that as well. And most probably by removing it. And I hope now both the problems as well as the solution is clear. So let's see a small test of it and do that in a small test Spider Python environment before we start doing it in the production. Thanks for watching and see you on the other side. Hello and welcome. And let's now see how to handle the dummy variables in production. So I have imported the pandas and also have this data frame created from this dictionary. Then I'm also creating the dummy variables. And for now, I'm not dropping the first dummy column. This is followed by extracting the column names from this one hot encoded data frame. We have done these things earlier as well, and they are pretty simple. So let me just select these lines and execute them. It should be done in a flash, and we have this encoded xtrain with 7 columns now. So it will have 4 for these 4 names, 2 for these 2 educational categories, and then 1 for the income. Then this variable of train enc calls is an object of type index, and if you open it, we will have these columns over there. Great. Next, let me simply paste the code for serializing this index object. So we import the joblib, create the file path and its pickle name, and finally dump this index object as this obj file. With that, we will be able to recover or load this column index object anywhere. Alright, so select and execute these lines as well so that we have the serialized object created. Great. And this completes the processing required for dummy variables in the training experiment. So now let's see what we need to do in production to make use of this index object. And let's call the loaded columns as reference columns and code it as ref underscore calls, and that is equal to joblib dot load, and within the parenthesis this obj underscore file. And if this had been a different program, you may have to even import the joblib and also provide this path of obj file. But here I'm doing it in the same one. That's why I'm not importing it and not recreating the path. Okay, then let me create the production input, and I'm simply going to copy and paste it here. It's a simple data frame called xdeploy. I'm creating it in a very similar manner as the earlier train from this dictionary. Also creating the dummy variables and getting their column names in this deploy underscore calls variable. Pretty simple. So first, let me select and run these lines starting from ref calls until here, and then open the deploy calls from variable explorer and also the ref underscore calls. And that way we will be able to see firsthand the problem that we discussed. And as expected, the deploy calls have just these 3 columns, whereas the reference columns have 7. So we need to add these 4 missing columns to the input data frame of the deployment. So let's first extract the missing columns as missing underscore calls equals to, and now we are going to use a method called difference of this index object. So let me code it first, and then it will be clear. So that's going to be ref underscore calls dot difference, and within parentheses the index object whose difference we want to calculate, which is this deploy underscore calls. So what this difference method does is it gives all the column names which are present in the ref calls but not in the deploy calls. Let me execute it and then view it so that it will be clear. And then let me open all the 3 column index objects of ref calls, deploy calls, and the missing ones. And now if you compare these 3, you will see the missing columns over here. Pause the video if you want and compare them. Great. Let me close them for now. And now let's add the missing columns to the xdeploy enc data frame. So to extract them one by one from missing calls, let me just use the for loop as for calls in missing underscore calls colon, and in the next line x underscore deploy underscore enc, and within the square brackets the calls equals to 0. Great. Select and execute this for loop, and then open the x deploy enc. And there you go. All the earlier missing columns are now added to the production data frame. It looks correct, but there is one last problem, and that is these columns are not in the same order or the sequence as the training column names. If you remember, we had income first, then name Bill, then name Jitesh, and so on. So we just need to do some small trick to bring them in the order over here. The code is pretty simple to do that. All we need to do is provide this same data frame of x underscore deploy underscore enc equals to, and let me copy and paste this same data frame name, and then within the square brackets provide the index of ref underscore calls. All right, and select and execute it. And then if you open this data frame from the variable explorer, you will have a data frame in the same manner that our model or any other step after the hot encoding will require. I hope it is clear until this point. Great. So now the last thing that I want to show you is what if we have a category here that was not present in the training data. So let me just change this postgrad to postgrad1, and then select these lines starting from this data frame until the end and execute them. Open the x deploy enc once again, and there will be absolutely no problem here as far as the format of the data is concerned. And it will also not have the postgrad1 category as the dummy column, because when we chose the ref underscore calls in this statement over here, it got omitted. The postgrad1 got omitted. Now it is up to you how you want to handle such a situation. Either you can proceed with this data, or you may want to check if there is an unknown category, and then maybe provide some message back to the user. So let me show you how to check that extra category or column over here. For that, we are going to make use of this same difference method. But now we will change the order of these index objects. And let me collect the extra columns in a variable as extra underscore calls equals to, and first now we will provide deploy underscore calls dot difference, and within the parenthesis the ref underscore calls. Now by reversing the placement of these two indexes, what has happened is it will first check all those columns which are present in this deploy calls but not present in the reference calls. That's what it is going to provide us. So let me select and execute this line, and then things will be clear. And then open the extra calls, and you will see this one additional column for postgrad1 category over here. And in case there is no unknown category or there is no new additional category, this index will have no element here. So in case you want to check whether any extra column is present or not, you can simply check for the length of this extra calls. All right, and that will give you whether there is any unknown category in the production data that was not available during the training. After that, you can either stop the processing by sending an error message or just sending a warning message that you are ignoring the category, or do whatever your business demands in that particular situation. Great. And with all of that covered, we are now ready to train the model as per the production requirement. And we will then register it, deploy it as an inference pipeline as well. So let's see that in the next few lectures. As always, it's a pleasure to teach you. Thanks for watching. Welcome back. And let's now proceed and deploy the actual model in this series of lectures. So in this lecture, let me first summarize this script, which trains a model and creates the pickle file. So as usual, we access the workspace and the dataset, create the experiment, and start the new experiment run using start logging method. We have seen these steps earlier as well. Then we read the data in this df. And here I have made some changes compared to earlier script. Earlier, we were creating the dummy variables and then splitting the dataset into x and y. But here, first I'm creating the x and y and then applying the get underscore dummies method. This is only to bring in the consistency in the production run and this one, the training one. Because in prod, we will only have x. So it's better to deal with x separately even during the training. Then we are storing the column names in this train enc calls as an index. And the rest of the steps are pretty much same as before, which is splitting the data in train and test, creating the object of a random forest classifier, fitting the data and storing it as a trained model. Then we move on and predict the test data, then calculate the accuracy and finally log it. Then similar to the dump or serialization that we saw earlier, I'm creating a serialized object using this dump method. But instead of creating multiple serialized objects, I have put them in this list one after another, and then combine them to this file of models.pickle. So remember, because I'm combining these two objects and putting them in one file, when we unpack it or deserialize it, we need to collect them in the same sequence. So we will have first this index object, and then we will collect the actual model. And we will see that when we create the production script. Then another thing is, if you have noticed, I'm storing these pickle files in outputs folder. That means whenever the run is complete, this file will be automatically uploaded to the experiment run. For now, let me select all these lines and execute them. And it will start processing here. And now remember, I'm creating and running this experiment locally. But if you want, you can use any of the other previous methods to run an experiment. All we need to do is create this serialized object of trained model as well as the transformations or the column index. Great. So let this experiment run for some time, and I will see you in the next one where we will register this trained model to our Azure ML workspace. Thanks for watching. Welcome back, and I hope your experiment run is complete. So for the next step, we will require the reference of this run to register the model. And by reference, I mean the run object, which we can retrieve using the run ID. So let me first get the run ID from the experiment object. So that will be experiment dot get underscore runs with 2 parentheses. But this is a generator type of object. So to convert it in our list, let me typecast it as a list before this experiment and put this entire thing in the parentheses. Great. Select and run this line and give it some time, and it should provide all the run IDs in this experiment. For now, we have just one. So note down and copy the run ID from here from the console. Now, using this run ID, if you want, you can register your run as a model inside this script itself. But just to make it a bit more modularized and show the things separately, I'm going to keep the model registration in a different program. So let me open a new file. So in this new file, I have imported the workspace as well as the model class, then created the workspace from config, and also created the run object from this run ID. Make sure you paste the run ID from the previous experiment and paste it here. Now, there are 2 ways we can register a model to the AzureML workspace. One is using the register model method of this run object, and the second is by using the model class and uploading the pickle file, the local pickle file. So in this lecture, let's see how to register the model using this run object, and then in the next one, we will see how to upload our existing local pickle file and create or register the model. For this one, all we need to do is invoke the method by typing new underscore run dot register underscore model, and within parentheses, we need to provide certain parameters, and they can be in any order. So first, let's provide the path of the pickle file as model underscore path equals to, and this path is the path beyond this run ID. So we uploaded the pickle file to outputs folder, and that's why I'm going to specify it as outputs/models.pkl. So this is the path of the output folder within the run ID inside the workspace, and not the outputs folder on our local machine. All right. Then a comma, and on the next line, let's provide the model name as model underscore name equals to, and here you can provide any name as a string. So within quotes, let me provide adult income underscore models. And next, let's add a few tags to this model as tags equals to, and this will be a dictionary. So curly brackets here. And now here we can provide any key value pair that we think will help us identify the model. And we can even use these tags for retrieval at a later stage. Because over a period of time, you may develop multiple models, and you should be able to identify them beyond the name. So we can have some additional information using these tags. So for now, let me provide the first key as source, in quotes of course, and then a colon, and then the value for it as in quotes again, SDK-run. So this is the model created using SDK and registered using the run object. A comma, and another key for algorithm, in quotes, colon, and let's provide it as random forest. Okay. Next, let's also provide the properties of this model as properties equals to, and this is also a dictionary of key value pair, so curly brackets. And now once again, we can provide any key and any value here. It's completely for our reference. But then you may ask how it is different than tags. Well, the major difference is we can delete the tags, but we cannot delete the properties of the model. All right. So let me add the first property as in quotes, accuracy, colon, and let's retrieve it from the new run metrics as new underscore run dot get underscore metrics and normal parenthesis. Now this again will provide us a dictionary of all the metrics. So let's extract the accuracy and provide a square brackets towards the end and the key of accuracy in quotes in all small caps. Okay, I hope you are still with me. And towards the end, let me provide the description for this model as a description equals to, and in quotes, let me provide it as combined models from the run. That's it. And there are a few more parameters, but they are optional. And in case you want to know them, you can simply go to the run class in the AzureML documentation and then scroll down a bit to the methods. And then click on this register underscore model method to see all the parameters and their description. Okay, for now, I'm going to go ahead and execute the code. So let's go back to Spider. So let me select this code and execute it and give it some time, and it should be done in 10 to 20 seconds. It's done for me, and it has provided this entire information of which workspace, resource group, and various other details of this model right here. And if you have been doing it along with me, congratulations on registering your model using the run ID. If you want to check it, you can do that by going to the AzureML Studio as well. And then click on this link of models. And right here, you will see our model of adult income. You can click on it and see all these details here. You can also click here to edit the tags. So you can either add or even delete these tags here. Great. Now that covers registering the model using the run object. In the next lecture, let's see how to register a model using the local pickle file and using the model class. As always, thanks for joining me here and have fun. Welcome back, and today in this short lecture, let's see how to register a model using the local pickle file and the model class. It is pretty simple and very similar to the model registration using the new run. So first, let me just copy and paste these lines of new run.register. And now let me delete the new run.register, and instead of that, type the class of model dot and the method as register. And then inside the parenthesis, we need to tell this method where to register it, which is our workspace. So the first parameter here will be workspace equals to ws, comma, and then rest of the parameter names are same. But here we can provide the local model path as dot slash outputs slash models dot pickle, because that is where I have kept it during the joblib dump. Then let me also change the model name and add underscore local over here instead of the run. And then these changes are just to identify it separately, nothing else. So change the tag to SDK local instead of this run once again. Then I'm going to keep the algorithm as it is. Then accuracy, I'm going to hardcode as 0.7866. And if you are registering it as part of your experiment run, then you can simply provide the score variable over here. All right. And finally, let me also change the description as local instead of run. That's it. Isn't it simple and very much identical to the previous step? So then select these lines and execute them to register your model. Give it some time and your model should be registered. It's done for me, and just to verify it, let's go to the studio. So go to this model, and if you're already there, simply refresh it to see our new model over here. Great. Now, only difference that you will see here is that it won't have the run ID, because we didn't create it using the AzureML run. So majority of the time, I would suggest create it from the experiment run. That is when you are creating the new experiment from here onwards. But it is possible that you may have the previous models done outside the AzureML framework, and you may want to register them here and then deploy them. In that case, you can make use of the tags to add any additional information here. And you can use this model class and its register method to register those external models. All right? Great. And I hope now you know how to register a model using the run object as well as any local pickle file. So congratulations on learning another important exam objective. In the next lecture, let's see how to retrieve the information of the registered model, and then we will begin the final deployment as the real-time web service. Thanks for watching. Welcome back, and once again this lecture is going to be pretty quick. So to list all the registered models in our workspace, all we need to do is use a method called list. So if I simply type the class of model dot list and the workspace of ws inside the parenthesis, and then select and execute this line. Give it some time, and when it is done executing, you will see this list of model objects printed on the console. So it has this workspace information first, then we also have the model name, its ID, version of the model, various tags as a dictionary, as well as the properties of the model. And as you can see, this is not very much readable. So let me print it in a for loop, and please allow me to copy and paste the for loop for now, because it is pretty simple and just using the tags and properties dictionary. There you go. So as you can see, I'm first extracting one model object at a time from this model.list, and then printing the model name using model.name as well as its version. Pretty simple. Then I'm also printing the run_id by using the model.run_id attribute. This is followed by these two for loops for the two dictionaries of tags and properties. Again, they are pretty self-explanatory. It's simply extracting the property name from this dictionary and then use that to get the value in the prop and then print it. The same thing is done for the tags as well. Great. So once again, let me select and execute this for loop. And there we have all the model names, their run IDs, properties, and tags nicely printed over here. You can use it to get some reference or simply write it to some sort of file if you want. This could be required to simply know the status of how many models are registered in your workspace as well as their purpose. Great. And with that, we have come to the end of this lecture, and let's proceed to deploy these registered models now. As always, it's a pleasure to teach you. Thanks for joining me here. Welcome back. Now, one of the first steps, if you remember from the implementation of the designer pipeline, is to provision the inference cluster. These are usually the Azure Kubernetes cluster, or also known as the AKS clusters. So when we used to provision them using Studio, we used to provide the region, type of machine, or VM size. Then in the next screen, we used to provide the cluster name, cluster purpose of whether it is for production or for development and testing. And we also provided the number of nodes. This was the basic configuration that we have to provide as part of provisioning configuration for the AKS compute cluster. And once we are clear about these parameters, it is just a matter of knowing which class and which method to use while provisioning it using SDK. So let's do it. So here we are, and as usual, I have created the workspace object from this config file. Then I'm also creating a custom environment that will be required when we deploy the web service. These are some typical steps that we have done earlier as well. And now, to create an AKS compute cluster, we need to import a class called AKS compute. So that will be from azureml.core.compute import AKS compute with A and C capital. And now let's give some name to this cluster as cluster underscore name equals to, in quotes, AKS dash cluster dash 001. Okay. Then next, let's create the provisioning configuration for AKS as AKS underscore config equals to the class of AKS compute dot the method of provisioning underscore configuration. And then within the parenthesis, let me first specify the location as location equals to East US in quotes, comma, and then the VM size as VM underscore size equals to the same that we used earlier as in all caps standard underscore D11 underscore V2. Another comma, and now let's specify the number of nodes as agent underscore count equals to 1. Because we are only going to test it, 1 is enough. But if we specify such a low number of cases, we have to specify the purpose as development and testing. That parameter is cluster underscore purpose equals to, in quotes, dev test with D and T capital. For production, this will be fast prod with F and P capital. Alright. So we now have the name. We have also created the basic provisioning configuration. So now let's go ahead and deploy it. For that, we need to import another class called compute target as from AzureML dot core dot compute import compute target as one word and CNT capital. And now we can create the AKS cluster as this class of compute target dot the method of create, and within the parenthesis specify WS for the workspace, cluster underscore name, and finally the provisioning configuration that we have in this AKS underscore config. Hope it is clear up to this point and how we are provisioning the AKS cluster. Now this create method will return an object, and we need to use that object when we are deploying the web service. So let's collect it in a variable as production underscore cluster equals to this entire statement. Great. And when it creates it, let's make the script wait for completion as production underscore cluster dot wait underscore for underscore completion, and within parenthesis show underscore output equals to true. Alright, great. So remember these two classes of AKS compute and compute target, and this two-step process of first creating the provisioning configuration using this method, and then finally combining all the parameters in this create method. Great. And if you're doing it along with me and have a paid subscription, I suggest not to submit it just yet. There are a couple of more lectures for the inference configuration as well as creating the web service script. You can wait for those lectures to complete before you provision the AKS cluster. And if you're still during the free trial period, you can go ahead and select all these lines to execute them. It's going to take a considerable time, almost 10-15 minutes, or maybe even more. So I'm simply going to end the lecture here and come back for creating the web service configuration on this AKS cluster. As always, thanks for watching. Welcome back. My AKS cluster deployment went fine, and we are just a couple of steps away from deploying the web service now. Okay, and now that my cluster is ready, all I need to do is provide the inference configuration and the deployment configuration. And if you find these names a bit confusing, well, just consider inference as all the software components and their configuration, and deployment as the hardware configuration. You can search for AzureML inference config, and it will show you this web page which has all the details about it. So things such as what kind of environment is required for the web service, various packages that needs to be installed, then which script will be run while deploying, as well as when the web service is called. And because there is going to be a script, we also need to provide the location of the script. Then whether we want to enable the CPU or GPU, all of that is part of the inference config class. Then let me go to the deployment configuration. So here we have this class of AKS web service, and within that, if you scroll down, this method of deploy configuration is the one using which we can specify the hardware configuration for the web service deployment. So this hardware configuration such as auto-scaling, number of CPUs and GPU cores to use, amount of memory to use from the deployed cluster, as well as their limits, all of this is specified using this method of AKS web service class. Great. So let's go back to Spider and then code for them. First, let me import the class of inference config as from AzureML dot core dot model import inference config as one word with I and C capital. Next, let me create an object of it as inference underscore config equals to the class of inference config, and within parentheses, let me provide the environment as environment equals to and the earlier environment of my env that we registered. Next, we need to provide the name of the script that we will run when we deploy the web service. Now, this script is a mandatory parameter, and in this script, we will unpack, or we can say, load the pickled objects of transformation and the trained model. If you want, you can do some other data processing inside this script, and we will see that in detail. But for now, let me provide that as a parameter of entry underscore script equals to, and for now, I'm just calling it as in quotes, scoring underscore script dot py. And then we also need to specify where to find this script as source underscore directory equals to in quotes dot slash, and I have created a folder called service underscore files. So all the supported files, etc. I'm going to save in this particular folder. If you want, you can create your own structure. This is not mandatory that it has to go in this particular folder. Unlike the outputs folder, where whatever we keep in that outputs folder, it will be picked up. So service folder or this one is not like that. Okay. So this is the minimum that we can provide, and then leave rest of the parameters to their default values. Great. Then next, let's create the deployment configuration using the AKS web service class. So let me import it first as from azureml dot core dot web service import AKS web service, and as you know, it's one word with A and W capital. Then let's specify the deployment configuration using the method that we saw earlier. And because this configuration needs to be provided while deployment, we need to create an object of it. So let me call it deploy underscore config equals to this class of AKS web service dot, and then the method of deploy underscore configuration. And within parentheses, for now, I'm going to provide just the CPU and the memory that our service can use. All right. And that also means we can deploy multiple web services on this cluster. And that's why we need to specify how many of these cores will be utilized by each of these web services. So the parameter for that is CPU underscore cores equals to 1 for now. And then the second parameter of memory underscore GB equals to 1. So it will use 1 core and 1 GB memory. That's all that is required for creating the inference and the deployment configuration. So to summarize it, all the packages and software related things go in inference, and all the hardware configuration goes in deployment configuration. Great. For now, if you have done this along with me, please do not execute these lines because it will give you an error that the entry script does not exist. Alright, now many of you must be wondering and itching to know what goes in this entry script. So let's see that in detail and the kind of structure, functions, etc. that is required for the entry script. And in the interest of time, let's code this entry script in the next lecture. Thanks for watching and have a great time. Hello and welcome. So we saw in the previous lecture, we have to provide this entry script. Now this entry script needs to do two things. First, when we deploy the web service, or you can say when the service is loaded, it has to unpack or load various models that we have created. These models we have supplied in the PKL format. So first they need to be loaded. Then it waits in that state for the input. And once we provide the input, it needs to do the transformations and then predict the dependent feature if we provide the data in a particular format. I hope this is clear. And now, as part of the entry script, we need to create these two functions called as init for this initial deployment and run when we want the web service to run and provide the predictions. Okay, great. So let's go ahead and code these. So here I am, and to define any function, as you know, we simply use the def keyword. So first, def space init with two parentheses and a colon. And now let me code this function in the reverse order, and you will very soon know what I mean. So let's unpack and load the two objects of reference columns and the trained model. So that will be ref underscore calls, comma, predictor equals to joblib dot load, and within the parentheses model underscore path. That also means we need to import the joblib. So at the beginning, let me import it as import joblib. Great. Now, if you remember, we dumped both the reference column index as well as the trained model in one pickle file. And that's why when we load them here, we need to collect them in two variables. Okay? But it is giving us this error that we have not defined this model path. So let me do that before this load as model underscore path equals to the class of model dot, and the method to get the model path is get underscore model underscore path, and within the parentheses we need to provide the name of the model in quotes. So that will be adult income with A and I capital underscore models. I hope you remember this was the name we have given to the models.pkl file. Great. Now this statement also means we need to import the model class, and let me do that at the beginning itself. So that will be from azureml dot core dot model import model. All right, and this more or less appears to be okay for now. And if you run this code as part of your entry script, it is going to go fine, that's for sure. But remember, we are going to use this ref underscore calls as well as the predictor in another function of run. And these two right now are local variables defined within the scope of this init function. And if that is the case, we won't be able to use them in the run function. So to make them available across all the functions, we can declare them as global variables. So right after this init definition, let me type global space ref underscore calls, comma, predictor. So this will now define these two as global variables. Great. And that now completes the init function for us. And in the next lecture, let's see how to code the run function for making the predictions. Basically, we will be using these two models, and we will be doing the hot encoding for the production data using this index, and then use the predict method for this predictor. And I am super excited to show that to you. As always, thank you so much for watching and have a great time. Welcome back. Now, before we start working on the run function, I thought of taking a slight detour for those who are new to web service creation. So in this lecture, we are going to learn about the JSON built-in package of Python and how we can convert the Python data types in JSON format. If you're already familiar with this package, you can skip this lecture. All right? Great. So let's begin. As you would know, JSON is a syntax for storing and exchanging the data over the network. It is a text string written with a JavaScript object notation, and data is stored in a typical key-value pair, similar to Python dictionaries. So let's say we have a dictionary as D1 equals to, and within curly brackets, in quotes, the key of name, colon, and the value as Jitesh in quotes again, comma, and another key of age in quotes, colon, and let's say the value is 40. Now, if we want to convert this dictionary into a JSON format, then we need to make use of the built-in package of JSON and its function called dumps. So let me first import the JSON as import JSON, and then let's create a JSON string as D1 underscore J equals to JSON dot dumps, and within parentheses provide this dictionary of D1. Select all the lines and execute it. It should go fine. And let me just type D1 underscore J on the console over here and hit enter. And you will see this D1J as the JSON string. For Python, it is simply a string. Now, if we want to create a dictionary out of this string, we can easily do that by using another function called loads. So let me type D2 equals to JSON dot loads, and within parentheses provide the string of D1 underscore J. Select and execute it, and then open this D1 from the variable explorer as well as D2. And let me just adjust them, and you will see the exact same dictionary object with the same data in D1 and D2. I hope that explains how to convert the dictionary into a JSON string using this JSON.dumps and then reversing it using the JSON.loads. So whenever we call the web service, we will create the data in a dictionary format and then dump it as JSON to pass it to the web service. The web service can then do its processing and send the response back as another JSON object. Then, using this loads function, we can convert it into a dictionary and do our processing here. And if you're familiar with other programming languages, you can use their own functions as well. But there, you can only use our web service in an API mode. And we'll talk about these modes when we consume the web service. All right? Great. Now, before we end this lecture, let me also show one more thing that most of your production deployment will use, which is to convert the dictionary into a data frame. For that, let me first import the pandas as import pandas as PD, and then create the data frame as df1 equals to PD dot the class of data frame with D and F capital dot followed by the method called as from underscore dict, and within parentheses the dictionary of D1. So this from underscore dict method is going to accept a dictionary as an input and convert that into a data frame. But if you execute it like this, it will give you an error because this value of these keys needs to be an array, or you can say a Python list. So let me just put these values in a pair of square brackets, first for Jitesh and then for this 40. And now select all and execute it. When fine, and now you will see the df1 created as a data frame. Open it, and you will see the keys of the dictionary converted as the columns of the data frame, and the values are nothing but the rows. So if you add more elements to these lists, they will be converted into those many rows. All right? Great. And we are going to use both these functionalities in the entry script, and that's why I thought it will be good to refresh it for those who know it and teach it from the scratch for the newbies. Great. And with that covered, we are now ready to code the run function of our entry script. So let's do that in the next lecture. I hope you are enjoying these detailed explanations. As always, thanks for watching. Welcome back, and after the init function, let's now define the run function, which will be used every time we call this web service. So that will be def run, and because it's going to accept some input data, let me provide that as raw underscore data within the parenthesis and a colon. You can give any name here. I'm just using the raw data. All right. Now this raw data will be passed as a JSON object. So let's load it in our Python dictionary as data underscore dict equals to JSON dot loads, and within parenthesis this raw underscore data. Now in many cases this should be sufficient, but we may pass many other information such as headers, etc. as a part of this input raw data. So the correct protocol is to send the input in another dictionary inside this raw data dictionary, and I'm calling it as just data. And because we are the creator of the web service, we can create our own format in this fashion. That also means we need to provide the key of data inside the square brackets after these two normal parentheses. And of course, it is going to give us this error for JSON. So make sure we import it at the beginning itself as import JSON. All right, great. And now let's convert this dictionary into a pandas data frame as data equals to pd dot data frame dot from underscore dict, and provide this data underscore dict inside the parenthesis. We have seen this in the previous lecture. And next, let's create the dummy variables for this input data as data underscore enc for encoded equals to pd dot get underscore dummies, and data inside the parenthesis. Again, make sure that pandas is imported as import pandas as pd. Great. Next, if you remember from the hot encoding for the production lecture, we need to get the new column names from this encoded input data. So that will be deploy underscore calls equals to data underscore enc dot the attribute of columns. Next, we need to check for the missing columns in this deploy calls. So as we have seen earlier as well, we can get that using the difference method of this index object. So missing underscore calls will be equal to, and now we will make use of the unpacked object of ref underscore calls, which is precisely the reason we sent it as a pickle file. So let me type ref underscore calls dot difference, and within parenthesis deploy underscore calls. All right. And if you have attended all the previous lectures, you should not have a problem in understanding this. I am deliberately doing this line by line, even though we have seen these steps earlier, because this is the most important part in the entire deployment. Rest of the things were just configuration. The main processing is going to happen right here in this run function. And I hope you are okay with a little bit of slow pace here. And all the intelligent folks, thanks in advance for being so patient. Great. Next, let's add the missing columns with 0 values using a for loop as for calls in missing underscore calls, colon, and in the next line, data underscore enc, another square bracket, and calls inside that, and this is equal to 0. So this will take care of adding any missing columns. And now let's reorder them and also remove any extra columns as data underscore enc equals to, once again, data underscore enc and ref underscore calls inside the square brackets. Great. And now we are ready to pass on this encoded data to the predictor for predictions. So let me collect the predictions in a variable with the same name as predictions equals to the trained model, which is unpacked in predictor dot the method of predict, and within the parenthesis the data underscore enc. Great. And now when this line will be executed, it will return the predictions as an array. So we can actually dump it as a JSON object and return that. But I want to return the actual text of whether it is less than 50k or not instead of just zeros and ones. So let me declare a list as classes equals to, and within square brackets and within quotes, less than 50k as the first element of this list, comma, and in another set of quotes, greater than 50k. This also means I can make use of the predictions of zeros and ones as an index to fetch this description, because the zeroth element will be less than 50k and 1 means greater than. I hope you are still with me. So let me define another list where we are going to append these values as predicted underscore classes equals to, and a pair of empty square brackets. And let's now append the predictions in a for loop as for prediction in predictions colon, and in the next line, let's fetch the predicted class values as predicted underscore classes dot append, and within parenthesis classes, and then the index will now be this prediction. So within square bracket prediction. And I hope now you understand why we created this list and used the predictions as an index to get the respective text. So even though we are going to send one record at a time for now, it is very much possible that you may get more than one record as an input. Of course, the way you create the JSON will change, but this code will be able to handle it with minimum changes. All right. And now finally, let's return the predicted value as a JSON object as return JSON dot dumps, and within parentheses, this list of predicted underscore classes. Great. And that completes the coding for both the init as well as the run function of the entry script. If you want, you can have some other functions and do some other processing there by calling them from init or run. But as long as we have these two functions and they are coded right, we won't face any issue. Also, please make sure all the packages and modules are imported at the beginning. And if everything is fine, we are now ready to deploy this web service. So just to summarize, we imported these packages which will be required. Then we have these two functions of init and run. Init will be called when we deploy the web service. So it will unpack all the models and create this ref calls and the predictor model from the pickle file that we dumped. Then the run function will be executed every time we call this web service for prediction. So it will accept the raw data as an input. It will then unpack it and dump it as a dictionary using this JSON.dumps. We then do the data transformation using this ref calls, and finally do the predictions on this input data, and also using this for loop and the small list here to pass on or return the predicted classes. Great. And now let's go back and do the deployment using various configuration objects that we have created. I am super excited as we are so close to see the real usage of the data science and machine learning. As always, it's a pleasure to teach you. Thanks for joining me here. Welcome back, and now let's finish coding this deployment job. So in order to deploy the web service, we are going to use the deploy method from the model class. So first, let me import the model class as from AzureML dot core dot model import model with a capital M. All right, and now let's deploy the web service as service equals to model dot deploy with 2 parentheses. Now everything we have created previously will go as various parameters to this method. So first, we need to specify the workspace in which this web service will be deployed. So that will be workspace equals to WS. Then the second parameter is the name of the service as name equals to, and within quotes, I'm going to call this as adult income, everything in small case, dash service. Then the next parameter is about the models that this service will use, and we can use more than one model for this service. So that will be models equals to, and the model name inside the square brackets as model. Now, this model has to be an object of a model type created from one of the registered models. So we need to create this object before this deployment, and let me do that before this service statement as model equals to ws dot models, and within square brackets specify the name of the model in the quotes. If you remember, we registered our model as adult income with A and I capital underscore models, and this has both the model as well as the data transformation. So we use this model's properties of the workspace. So majority of the time you will see that things such as experiments, models, then data sets, data stores, these are all the properties of the workspace. And we can get that by simply typing ws dot and the property name. And majority of the time it will pass it on as a list. Great. Now let's complete the rest of the parameters of inference config, deployment configuration, and deployment target. So first, inference underscore config, and this will be equal to the inference underscore config that we created right over here. So provide that. Next, we need to provide the deployment configuration as deployment underscore config equals to the deploy underscore config, the one that we have created. So as you can see, everything is now falling in place. Whatever configuration objects that we created is now being used in this service object creation. And the last one is where it will be deployed. I'm in the actual server or cluster which we have in this production AKS cluster. So the parameter name for that is deployment underscore target equals to production underscore cluster. Great. And this is going to deploy our web service on this cluster using these configuration parameters. And as always, let's wait for the processing to finish by typing service dot wait underscore for underscore deployment, and within parentheses show underscore output equals to true. That's it. And we are now done with everything that is required for web service creation. So in the next lecture, let's just do a recap of everything we have done so far and then submit this service deployment job. As always, thanks for joining me here, and I'm pretty sure you are excited to deploy it as a service. We are only a few minutes away from it. Have a great time. Hello and welcome. We have done great amount of work by now. When we began this section, we first understood the concept of serialization and did a small demo of it using joblib and this scalar. We then deserialized the scalar using joblib's load function and saw how the clone behaves in exact same manner. We also understood the problem in handling the dummy variables in production and saw the solution of it by serializing the index object. We then used it along with the difference method to take care of the missing columns. And this formed a good basis for all the actual steps which are required for the deployment. So naturally, after that, we ran the actual training experiment and uploaded the pickle file to the outputs folder. This was then followed by the model registration as well as the understanding of using JSON with dictionary and the data frame. All of this was then used in creating the entry script, which requires these two functions of init while deployment and run while making the requests. We also saw how to provision an AKS cluster using various inference and deployment configurations. And finally, we coded the model.deploy method to bring everything together to deploy the web service. Great. So as you can see, I have done some minor changes to this script. I have added a few print statements here and there to measure the progress. Then for this AKS cluster creation, I have added this if block, which if you remember is very similar to an earlier submit job. All we are doing is checking if the cluster is already provisioned or not. And then accordingly either create a new one or simply use the existing one. Alright? And now we are ready to submit it. So let me select all these lines and hit Ctrl+Enter to execute it. It's going to take a considerable amount of time because I actually deleted the earlier cluster. So it's going to do everything from the scratch. And if you are doing it along with me, you can take a long break of 20-25 minutes. But if possible, keep checking it every now and then, just to make sure you didn't do any mistake or anything like that unknowingly while you were coding these. So let me pause the video here and come back once it is done. And finally, after almost 10 minutes, the service deployment is completed successfully. So let's now go to the Azure ML Studio and check its details. And once you are here, click on this endpoint. And there you go. We have this adult income service over here. Click on it. And you will see the details of this endpoint or the web service, such as its service ID, its deployment state, which is healthy, and it means the service is available. If you want to check what different status of this transition state means, simply click on it. And you will see these 5 different states of it. Simply go through it, and they are pretty straightforward in understanding. All right? So let me go back to the service endpoint now, and scroll down a bit. You will see various other details here, such as its URI for the REST endpoint, and the CPU as well as the memory that it is using. All right? And then click on this tab of Consume, and wait for a few seconds until the basic consumption information is shown over here. And don't you worry about this error that it could not produce the Swagger document. It is required only for the testing purpose. For production and testing in a program, this is not required. All we need is this REST endpoint. So simply make a note of it, or just copy and keep it somewhere, because we want to use it in consuming the web service. Then once again, copy and keep this primary key very handy, because this will be used for authentication purpose. Great. So now that our web service is deployed and the URI along with the keys are ready, let's now use it for some real-time predictions. So let's do that in the next lecture. As always, I am super excited to show it to you. And once again, thank you so much for joining me here and in this course. Have fun. Welcome back. And now that our web service is deployed, let's get some predictions from it. So I have already coded this program to test the web service, and there is nothing new in this program. Just the structure is what you need to understand. So we import the workspace and create an object of it using the config. We have done this millions of times. We then access the web service using this workspace object, and as we did for models, we can also access the web services by using this property of web services. And inside the square bracket, we can provide the name of the service that we want to access. Because this web services will simply return the list, and when we provide the name of the web service, it will fetch the one that we require. Then again, we import JSON, created this dictionary, and I have simply given some random values here for age, working class, and others. Also, make sure that the values are provided as a list so that it can be converted into a pandas data frame. Then here, we are first providing this entire dictionary as the value for the key data. Remember, we are going to use this data as the key in the entry script. And that way, if you want, you can pass on some other keys here, such as headers or any other logging mechanism, such as which channel it is, and so on. Then here, we are just dumping it in this JSON_data. And this JSON data is then passed as the input data to this run method of the web services object. As you know, this web service is going to return a JSON dumped object from the entry script. So here, we simply load it back using JSON.loads and collect it in the predicted classes. Great. And as I told you, there is nothing new here. Few lists, few JSON statements, and few dictionaries. You just need to remember the sequence and structure of the things here. Alright? So now, are you ready to see the output? Well, I sure am very eager to test it. So let me select all the lines and hit Ctrl+Enter to execute them. It shouldn't take long to execute it. Remember, the model, etc. is already trained. So this should be pretty quick. And there you go. It has predicted this new person to have an income greater than 50K. This is absolutely amazing. And I'm really thrilled to show you the final outcome from the model training to the deployment as a web service. And I would suggest just play around with these values. Try different values here and see for yourself what it predicts and how it predicts. Great. Now remember, what we have done here is access this web service using the workspace. But what if we don't have access to the workspace? Or we do not want any random user to get access to the workspace? Well, that's when we provide them a key and they can call the web service as an API endpoint. And that is precisely what I'm going to show you in the next lecture. As always, thanks for joining me here, and it's such a pleasure to teach you. Have fun. Welcome back. And now if you remember, when we viewed the web service using Studio, we had this endpoint information over here. So this URI that you see is what we can use or send to others who want to test it. Then we also have this key here, using which we can authenticate any request to this URI. And this is all that is required if you want to test or send requests to this web service. And that goes irrespective of which programming language you use. With just these 2 pieces of information, you can start making the predictions. Or you can deploy it here, and if there is some other developer to whom you want to give this information so that they can use in their application, you can send the URI and the primary key, and then they can make use of these predictive models. Alright, so let's go back to Spider and see the program that I have created for testing this API. And here we are going to use the requests library within Python. It's also known as the HTTP for humans. Well, I'm not going to explain the entire functionality of this library. We will specifically look at the steps required for making the API requests. So the first step is to get the scoring URI, which is nothing but the endpoint link that we saw earlier. Then we prepare our data in the same manner we did for the earlier call from the workspace. Then the next two steps are a bit different than the previous call. Here, because we are not going through the workspace authorization, we have to use the authentication keys for accessing the endpoint. There are multiple ways to send this key, and I'm sending it as part of the headers. So we need to create the headers as well. Then, using this URI, header, and the data, we make a POST request. Now, there are multiple types of requests that we can send to an API. Typically, POST is when you want to submit the data securely in the message and not in a URL. Then, after the request is processed, we collect the response in JSON format, deserialize it to Python, and then print it. Now, if these steps are clear, rest of the program is just the implementation of it. So, as you can see, we first import these libraries. Then I have copied and pasted the URI for our web service as a string. Then, similar to previous call, we create this dictionary for our data and then dump it using the json.dumps. You must have noticed that I have made some changes to this data so that we can see some different output this time. Next, we create this key variable, and this key is the same as the authorization key that we saw on the endpoints page in Azure ML Studio. We then add this key as the authorization parameter to the header, and this is the format for it, where we concatenate the key with this bearer keyword so that the request library and the endpoint can authorize it. So the bearer of this key will get the access. Next, we make a POST request using this request library and pass on the details of URI, JSON data, and the headers for authorization. We collect the response sent by this request in this variable with the same name as response, deserialize it, and then print the predicted class over here. Great. So these are the typical steps for the API call. Now, this is very, very simple call, and it doesn't have to be the most secured one, because remember, we are doing this for just learning purpose. But when you're doing it in production for your company, I suggest you follow the security guidelines laid down by your organization whenever you make these calls. The process will be more or less same in every organization, but just that there will be some additional measure to protect this key. Alright? So without spending much time, let me select all the lines and execute it. Now this should be done in a flash, and we have less than 50k returned by our deployed model and printed over here. Isn't it amazing to see the final output? All of that learning that we have done in the last so many lectures is for getting this response. And this response from this deployment and the deployment that we can make use of in the practical world. And if you noticed, this was done in a very short time because we don't have to access this workspace now. This is as good as accessing the API on the internet with some authentication. Great. And I'm sure you are now geared up for your DP100 exam and equally ready with an end-to-end understanding of a data science and machine learning project. Once again, thank you so much for joining me here, and it's always a pleasure to teach you. All the best for your exam and have fun. Hello and welcome. In this section, we are going to learn how to use the Databricks with Azure Machine Learning. In May 2021, Microsoft gave some major updates to the course curriculum of DP100. And if you go to this updated PDF, you may see a table giving all the details. And one of the major updates is related to the Databricks. Now, you will see Databricks and MLflow spread all over this document. And that can actually confuse you. And you may not even understand how to begin with it or what's the flow of it. Well, let me simplify it for you. So, one of the first few things is to create a workspace of Databricks, which is similar in nature to Azure ML Workspace. And this workspace allows us to create our Databricks cluster, create and run our notebooks on this cluster. And once we have the Databricks workspace, we have to link it to the Azure ML Workspace so that they can talk to each other. So this is all part of our setup objective. Alright? And then comes, what can we do inside Azure ML using Databricks resources and the reverse? So that's why the next objective is to configure the Databricks cluster as a compute resource so that we can run an Azure ML experiment or some script on it. Great. Then next comes tracking of these experiments and script runs. And that's why the next objectives are around using MLflow for tracking the experiments running in Azure Databricks. And once we are done with creating the workspace, linking it, running the experiment, the next logical thing to do is to deploy it as an endpoint. And that is precisely this exam objective is about. So you may run the experiment inside Azure Databricks for all its advantages, but in the end, you may want to deploy it on an AKS cluster using Azure ML. And now, as you can see, these exam objectives have a very logical flow to it, starting with creating the workspace all the way up to deployment of the experiments. Also, using Databricks, we are trying to bring in lots of flexibility in the overall ecosystem of Azure Machine Learning. And then some of you may be wondering, what is this Databricks? And what is Azure Databricks? Well, in order to understand Azure Databricks, we need to understand what is big data, how the big data evolved from the earlier days of Hadoop MapReduce, then to Spark, and finally to Databricks. So let's do that in the next couple of lectures. And if you already know what is Hadoop and Apache Spark, you can skip the next couple of lectures as we cover some of the basics in them. But please don't forget to tune into What is Databricks lecture. So let me end this one here, and as always, it's a pleasure to teach you. Thanks for watching. Hello and welcome. So let's begin by understanding what is big data. Some of you who are already familiar with the basic overview or have gone through the free HD Insight course can skip this lecture. Now, because of the word big, it is easy to confuse it with the size of the data. So is it only about the size or there is something more? Well, let's find out. Big data is divided into two major themes. The first part is about the data processing and the data storage, whereas the second is about the analysis of that data. By data processing, we simply mean that the data is so voluminous or so big and so complex that the databases, such as traditional RDBMS of Oracle, MySQL and such, cannot deal with the data processing with the optimum speed. That does not mean that they cannot work. You can still work with the traditional data stores with a huge amount of such data, but the processing time and effort required will not make any business sense. You may even lose the competitive business edge by doing that. And when we say big data, we basically mean terabytes or sometimes even petabytes of data. Then the second aspect of big data is related to the analytics, which is to chop and change the data with certain techniques. And we do it in such a manner that it reveals the hidden insight from the data. And the data which is very much diverse, complex and large. So it's not just about the data storage, but how we process the data and what tools and techniques are applied to get more and deeper insight from the available data that we have. Now, Databricks along with the Azure ML addresses this particular part of the big data. Alright? And having said that, big data has some typical characteristics. And not everything that is huge can be classified as big data. You might have heard about the 3 V's. But there are a few more V's that define the big data. Of course, the first one, that is of volume of data. And imagine healthcare. You will have tons of data for various health-related aspects of a patient. There could be various images such as X-rays, videos of various scans, and so on. Even social media, for that matter, generates huge amount of data with every post. And that data can be very much valuable. And this value can be discovered if you know how to use it. Then the second characteristic is the variety of the data. In the days of mainframe, and even in the early stages of dot-com boom, the data was mostly text and structured data. But in the last 10 years or so, we have generated variety of data, right from the old typical text and structured data, digital images, videos, and much more. And processing such data and making sense out of it is beyond the capabilities of traditional databases. For that, you definitely require big data processing. Then big data is also associated with the velocity of data generation. You may have thousands of IoT devices and sensors, and they may be sending data every second. There could be tens or sometimes even thousands of tweets on social media, and that may be generated in a matter of minutes. The sentiment analysis of these tweets may require processing them and taking some action based on the outcome. Then there could be a few more examples such as Walmart, which processes millions of transactions every hour. And some of the advertising networks, they need to process hundreds of millions of events on social media for targeted advertising. All of this requires big data processing. Great. Then the next is the variability of the data. Now, variability of the data means data whose meaning is continuously changing and it is dependent on the context of the data. So, for example, if we had to build a chatbot to book a flight, we may have to give it enough data so that it can categorize these sentences because it can have completely different meaning for the word book depending upon the sentence and the context. Great. Then last but not the least is the veracity of the data. Data by its own nature is very messy. You may not have the data in a form that you always desire. And you may require huge effort to clean it before it can be used. And big data is associated with this aspect as well. So in a nutshell, when we say big data, it may have 2 or more characteristics of volume, variety, velocity, variability, and veracity. Great. And with that covered, let's now see what are different types of big data applications. The first one is for batch processing. You may have the data coming from different sources in different formats, sizes, and so on. You may have to clean it, reformat it, and maybe process it so that it can be made available for further processing. This is one of the most common ways big data is used. And in this type of application, it uses Hadoop, Spark, and Hive for batch processing of data. Then another type is for real-time processing of data. The data in this case is fed at a very short interval of a few seconds or even milliseconds at times. You may need to process it, present it, and also take some actions in real time. It could be due to sensors or social media, and particularly deal with the volume and velocity aspect of the big data. And finally, the predictive analytics require huge amount of data to be processed by an algorithm. Also, a machine learning or a prediction algorithm may require data to be collected and merged before it can be processed. And big data applications are also used in such predictive applications. The use of Databricks with Azure ML deals with this particular type of application. And considering the DP100 exam objectives, we will be focused on this rather than everything that we can do with Databricks. And typically for such predictive applications, we will use services such as Azure ML, Python, Spark with Databricks. Great. And next, we need to refresh or learn is how the Hadoop works, and that will help us understand how the Spark works. And from there, we will move on to the Spark and Databricks. So in the interest of time, let me do that in the next lecture. As always, thank you so much for watching. Welcome back. And now let's just refresh some of the concepts of Hadoop. Well, Hadoop is a distributed processing framework. So what we mean by that is basically it has multiple computers running in parallel where the data as well as the computing power is distributed. It's also open source and is provided by Apache. Now, because we can add nodes or computers at will, it will virtually scale up to thousands of servers or worker nodes in parallel. Then for storage, it uses a compressed file format known as Hadoop Distributed File System and MapReduce to do the data processing. Then resource management for such a cluster can be very demanding job as we are dealing with thousands of worker nodes and data is split across these nodes. So Hadoop uses YARN, which stands for Yet Another Resource Negotiator, to manage the resources within the cluster. And now let's try to understand this concept with an example. So let's say there's a large company which has got millions of transactions within a year, and we want to get a summary report for all the transactions in that year. Now, in a traditional system, you will write an SQL query to select these records. It will then go to our large database, which will have these records with their dates. And let's say you are dealing with a very large database of 12 terabyte. And let's say, hypothetically speaking, it may take up to 12 hours to retrieve these records and provide it as a response to the query. But because Hadoop uses a distributed environment and it has got multiple computers or nodes which keep these data across different computers or nodes. So when we run this query in such a distributed environment using, let's say, some Hive query, it will then hit the master node of the cluster. The master node will then run the jobs on these worker nodes, and let's assume the data is evenly distributed. So each of these worker nodes may have the records stored for each month. And when we fire our query, all the 12 nodes for 12 months start running the jobs and provide us the data for the entire year. And because they are running in parallel, theoretically speaking, we can say the job is finished in 1/12 of the time. It may not be the exact division, but surely much lesser than a traditional database system. And this is precisely what the Hadoop as a framework achieves. Now, Hadoop cluster typically has a master node and one or more slave or worker nodes. Then as every node is nothing but a computer, we have both the storage as well as the computing power available with us. The computing part of it is what we call as MapReduce, and the data storage is the HDFS or the Hadoop Distributed File System. The HDFS layer has a name node and a data node within the master. Typically in a standard implementation, you will see every worker node has one data node as well. The name node is like a directory of all the other data nodes within the Hadoop clusters. It keeps track of all the data that has been stored across thousands of computers on this Hadoop cluster. So it knows which block of the data is stored on which computer. And the data node simply stores the data. One file can also be stored across different computers, and many of these nodes keep multiple copies of the data. Now, this makes sure that the data is not lost, even if one of the copies gets corrupted for some reason. Then the job tracker, which is part of the MapReduce layer, assigns various tasks to specific nodes within the cluster. So, for example, if we are running a program to calculate the summary report, it will be assigned by the job tracker to various nodes where the data resides. It also tracks the tasks assigned using task tracker, and then the master node, which has information such as which nodes are currently working, who is idle, and where the work can be allocated. It also needs to tell the job tracker that it is alive, and every now and then it sends a heartbeat. Now, typically, when a new dataset or file is sent to the Hadoop cluster, it assigns the task of processing the data and then storing it to various worker nodes through this job tracker. And after that, a file can be stored across multiple nodes. So that storage can be either in part or in full. But as I told you earlier, big data is not just about Hadoop. The big data ecosystem is pretty large, as we can see from this slide. So what happened over a period of time was even the MapReduce of Hadoop was not sufficient, and it was not very user-friendly. So that's why few other products, such as Hive, which was specifically designed for SQL developers, Pig for data processing, and even Spark for real-time and in-memory computation was added. We even had HBase as a NoSQL database, and all these other supporting services. And this led to a huge set of tools and services as part of this ecosystem. It was not at all, and it's still not so easy to install and manage a big data system. And that's where the evolution of Spark and Databricks happened. And let's now see how it evolved, and finally, what is Databricks in the next lecture. As always, thank you so much for watching. Welcome back. And now that we know what is big data and Hadoop, let's move on and understand the journey from Hadoop to Databricks. Usually, this kind of evolution in such products is due to the issues faced in the previous one. So basically, Spark was introduced to take care of the issues with Hadoop, and Databricks was introduced to take care of issues with Spark. It is as simple as that. So then the natural question that you may have is, what were the issues with Hadoop? I mean, it was performing so well and gave us a new hope in performing the big data operations using distributed processing. Well, over a period of time, as the data grew tremendously, Hadoop became inefficient and would take a huge amount of time. Then another issue is with the support only for batch processing. Hadoop cannot do real-time data processing on its own. Also, as the ecosystem evolved, there were multiple products that were created to support Hadoop. And this led to a huge ecosystem with too many products around it. So if you had to take full advantage of Hadoop, you may have to install multiple products and have a team which knows all of them. Now, that's a bit of an issue for long term. And last issue, but not the least, of course, is the lack of in-memory processing. Hadoop relied on the data I/O to and from the disk, and that was also one of the reasons it wasn't fast enough. And that's when Apache Spark was introduced to take care of these issues. So Apache Spark, as per the creators, is a unified analytics engine. And what that means is it can do everything right from data processing all the way up to the machine learning at one place. And it can do that with large-scale data. Now, one of the biggest advantages of Spark is its in-memory processing capabilities. And because of that, it is super fast. In some studies, it has been found 100 times faster than Hadoop. And not just that, it also solves the problem of multiple products by providing APIs for development in Java, Python, Scala, as well as R. And of course, it surely supports the batch and real-time processing at a very high speed. So it's kind of one-stop shop for all your big data processing and analytics requirement. Alright? And now, let me also briefly explain the Spark architecture, because some of these terms here will be used when we start working on the Databricks. So similar to Hadoop, Spark also has a master node, and this master node runs the driver program. So whatever application program that we write is basically the driver program. Then inside that, we create the Spark context, which will connect with the Spark cluster and also has the configuration, connection requirements, and so on for the cluster. So it's a kind of a gateway or a connection between the driver and the Spark cluster. Then this Spark context can connect with the cluster manager to allocate resources for the applications. And once this is done, Spark then acquires these executors on these worker nodes. These executors actually get the data as well as execute the tasks. So similar to Hadoop master node, even this driver will have to be always in touch with the worker nodes. And if you have noticed, there is no mention of storage in this architecture. We have the cache memory where the data will be loaded and then tasks will be executed. That is because in principle, as we mentioned earlier, Spark is a unified engine. So it does not matter where the data is stored as long as these worker nodes can access it and load it in the memory. And that is some kind of flexibility for us. Great. Next, Spark also has a very small ecosystem and greater flexibility compared to Hadoop. So while you have the Spark core engine, which can be worked with using any of these languages using their APIs, we also have additional components such as Spark SQL, which I'm sure you must have guessed will be used for SQL processing of the data. Then we have Spark Streaming for the streaming or real-time data processing. MLlib is used for machine learning tasks. And then we also have the GraphX and Spark R as additional components. Now that sounds like a complete package and better than others as well. Then once again, you may wonder, what are the issues with this because of which we have to bring in the Databricks? Well, Spark is not easy to use. You really need to understand the core details of it to work on it very efficiently. So everything is command or programming driven and you have to create your own environment, including the cluster and so on, which can be very time consuming. Then Spark is not so great when it comes to collaboration among different users. Because remember, typical data related applications would start with raw data sources. Then they move on all the way up to machine learning predictions after the data processing and data engineering. So you need different types of experts such as data engineers, data scientists, DevOps professionals, and many others working on such applications. And Spark does not do a great job there. And last but not the least is the Spark was not developed as a cloud-first product. So it is not very friendly when we want to deploy Spark on cloud. And that's where Databricks comes into the picture. Databricks is a complete platform for better and efficient working with Spark. Remember, Databricks does not bring in any new technology. It still works with Spark and some other technologies. It's kind of a wrapper around Spark for better working. And it also provides a workspace similar to Azure ML Workspace, which kind of a place to collaborate various aspects such as Spark clusters, data required, notebooks, libraries, and almost everything that's required to manage Spark as well as its infrastructure. Now, because of this workspace, it's very easy to collaborate and integrate it with any cloud-based application. We can basically get the Spark infrastructure up and ready in a matter of minutes. So we can basically focus our energy on building a real business application. And before we end this lecture and start working on Databricks, let me explain in brief the high-level conceptual architecture of Databricks. So as I mentioned, you have the workspace at the top, which is kind of a wrapper around all the other components. And as a user, you will interact with this workspace, and it has all the user management and security features required for collaboration. So from the workspace, we can create the clusters, notebooks, experiments, and so on. Then under this workspace, we have various components such as Delta Lake, Spark, or we can even install libraries such as TensorFlow, Azure ML SDK, MLflow, and many more. And of course, we can connect with various cloud services such as Azure or AWS with absolute ease. We can also get the data stored in our Azure storage account, connect the Databricks with another Azure ML workspace, and even deploy the models on Azure ML. Remember, Databricks and Spark are the oceans in terms of functionality. There are tons of them. So for the purpose of this course, we will stick to these objectives and related topics. Alright? Great. So to begin with, in the next lecture, let's create our own Databricks workspace. As always, it's a pleasure to teach you. Thank you so much for watching. Welcome back, and now let's create the Azure Databricks workspace from the Azure portal. So log into your Azure portal and search for Azure Databricks in this search bar. Select this option for it. And on this screen, click on this Create Azure Databricks Service button. Now, this page is very similar to the Azure ML Workspace creation page. You can choose the subscription under which you want to create this workspace, and then provide the resource group as well. For now, I'm going to create a new one as Databricks WS001 and click OK. And then let's provide some name to this workspace as Databricks 001. Then select any region that's close to you. I'm pretty comfortable with the East US, so select that. And next, we need to specify the pricing tier for our Databricks workspace. For now, it provides three options of standard, premium, and premium trial. So let me go to the pricing tier page for Azure Databricks, and then things will be clear. So here I am on the Azure Databricks pricing page, and it's pretty easy to come to this page. Simply search for Azure Databricks pricing, and the first page will be this one. let me scroll down a bit. And here the first list of features is that of standard tier. Within that, you will see the all-purpose, which is the highest within the standard tier, and then the jobs compute and the jobs light compute. Now, the main difference, as you can see, as mentioned by Azure over here, is for whom it is designed. So data engineers will be okay to work with the jobs compute and the lighter version of it, but it is always recommended to use the all-purpose for the data scientists. And as you can see here, the features are pretty straightforward. So the Apache Spark as well as job scheduling is provided on all the three computes. But other features mostly related to working with notebooks is provided only in the all-purpose and job compute. Both of them also have some machine learning features as well. But when it comes to the teamwork and some data visualization, it can only be done in an all-purpose compute. So things such as concurrent clusters for multiple users, one-click visualization, integration with version control or BI tools, all of that can only be done using all-purpose compute. And as you can see, these are the tasks or features mostly used by the data scientists. Then scroll down a bit and you will see this premium tier, which is again divided into 3 workloads. So all these 3 premium workloads have all the standard features and also have some additional ones. So as you must have noticed, it is mostly related to the access control. So things such as role-based access to different users, JDBC authentication, audit logs, Active Directory integration, conditional authentication are all part of the premium tier. You can go down a bit and see various other pricing details as well. Alright, and I hope that's a good enough overview of the pricing tier. At least now, we are not in complete dark as to which tier does what. Great. So let me go back to the Azure portal. Now here you will see this third one of trial premium, which it mentions as free for 14 days. So irrespective of whether you're on a paid subscription or the Azure free trial, these 3 options will be available to you. And if you are still within the first 30-day period of Azure account and still have credits, it won't matter much which one you choose. You can easily go with premium. But just be a bit careful there. Databricks is one of the most expensive services of Azure. And if you accidentally leave it running, you may exhaust your credits pretty fast. For now, I'm going to choose the trial of premium. So it gives me all the features of premium tier, just that it is available on a trial basis for 14 days. So that is good enough for learning purpose. Great. And for now, that is all that is required for the basic configuration of the Databricks workspace. So let me click on review and create. And as usual, it will go through some validations. And once the validations are successful, you can hit this create button and it will start initializing and then submit it for deployment. Now, similar to Azure ML Workspace, this also takes a few minutes. It may even redirect you to another deployment progress page. So give it some time, maybe around 3 to 4 minutes. And after that, it should be done with all the deployment tasks. And if you see this screen, congratulations on deploying your first Databricks workspace. So let me click on Go to Resource. And it will show you this page of Databricks Service Overview. It's pretty standard with its status, resource group, location, and so on. You also have this option to upgrade it to premium from the trial. Then if you scroll down a bit, you will see all these options of documentation, importing data, and so on. But the most important one is this option of linking an Azure ML workspace with this Databricks workspace. And I'm sure you remember this is also one of the exam objectives. And we will surely see that in later lectures. For now, let me click on Launch Workspace. And in the new tab, it will open the UI for Azure Databricks Workspace. On the way, it may even ask you to choose one of your Azure subscriptions and will sign you in to the Databricks Workspace. And once you are done with signing in, you will see a page like this for the Azure Databricks Workspace. It's pretty similar to Azure ML UI. So you have all these options of home, workspace, from where you can manage the resources as well as the workspace users. You also have this tab for data, from where you can manage the data required for your Databricks applications. From clusters, you can manage your clusters by creating, updating, or even deleting them. We will see each of these options in much more detail when we start working with the scripts and also run the experiments using Databricks Cluster. For now, once again, congratulations on creating your Azure Databricks workspace. As always, it's a pleasure to teach you, and thank you so much for joining me here. Hello and welcome. And as you know, I have always been advising you to delete your resources after you are done with the hands-ons. And this surely saves some costs. For now, if you don't want to delete your resources just yet, simply watch this video and you would know what to do when the time comes. Now, in case of Databricks, when you want to delete your resources by going to this All Resources link, you will be surprised to see so many of the other resources getting created. You may have disks, network interfaces, IP addresses, storage accounts, security groups, and so on. And if you try to delete them, you may get an error. So please don't panic. I'm always there to help you. All you need to do is go to these original resource groups. So for Databricks, simply scroll down or up until you see this resource of Databricks workspace, and then click on this main resource group for it. Or you can even go to the resource groups tab and then click from there also. And then on this screen, delete this resource group by clicking here, then confirming the resource group name, and then finally deleting it. This way, you will make sure that every resource created as part of the Databricks workspace will be deleted. Give it a few minutes and refresh the screen every couple of minutes until you see them all deleted. And for the Azure ML workspace, it's the same process of deleting the main resource group. Apart from that, you may also have to delete another resource called Network Watcher. You will surely find them if you just scroll up and down or even in this resource groups tab. and then delete it in the end once you have deleted both the workspaces and the storage accounts and everything. Give it maybe 4 to 5 minutes, refresh it again, and surely all resources will be gone. Great. And I hope this calms you down in case you see so many resources getting created there. As always, thank you so much for watching. Hello and welcome. So before we start working on Databricks cluster creation, there are a few things that you need to be aware of. There are certain quotas, and we could have an issue if you don't have sufficient quota or limits. So first thing is about your regional CPU or virtual CPU limits. Most of the time it is set to 10. And to check that, all you need to do is search for subscriptions over here. Click on it and it will show you the list of subscriptions available under your account. Then click on the one that you plan to use. And then on this page, in this menu on the left hand side, scroll down up to settings. And there you will see the usage and quota. Click on it. And here you will see all the services, their location, and how much you are using. Now this number at the end is nothing but your limit under that subscription for that location. And because I use East US most of the time, let me select that from this all locations filter. So deselect all and let me type East US and select that. You can simply select whichever you prefer or is close to you as long as it has all the services of ML and Databricks. Then under this all services quota filter, again deselect all and search for total regional vCPU and select that. And now you will see the limit for it over here. And if you want to work with Azure ML and Databricks together without any issues, then you should have a limit of minimum 12 over here. Now, there are two ways of increasing your quota, but please wait until I explain the best method. You can increase your quota by clicking here on this request quota increase button, but it is slightly exhaustive and requests a lot of information. So instead of that, you can simply click on this pen icon for editing this limit, and then simply provide at least 12 over here as the new limit. Don't go beyond 20 as it may or may not be approved. 16 is more than required. Then click on save and continue, and most likely it will get approved instantly. Now, I'm not sure if this quota increase is allowed as part of the free trial, as I have used it a long time ago. And if not, then you may have to switch to a paid account just for a couple of hands-ons on this section. Great. Now, I have another paid subscription where I have raised my limit to 20. So all the best with your quota limit, and I'm going to leave it here for now. As always, thank you so much for watching, and let's get started with cluster creation. Welcome back, and I hope you have created your Azure Databricks workspace. And now let's see how to create a Databricks cluster. For that, click on clusters, and sometimes it may give some error or a message that it is unable to create or access the clusters. Do not worry about it, simply click on it again, or click on this Databricks icon, and then go back to clusters. And once you have accessed it successfully, it will show you a screen like that, which will list all the clusters that you have created over here. Right now, the list is blank, as we didn't create anything. So click on this link to create a new cluster. And now let me walk you through this new cluster form. First, provide the name of the cluster, and here I'm going to provide my DB cluster 001. Just some random name. Then you have this cluster mode, and there are 3 possible options as of now. So you have high concurrency, standard, and single node cluster modes. The difference, as you will be able to see, is about the number of concurrent users. So small data and a single user, the single node is more than enough. But remember, the single node will have or will not have any worker node. Everything is managed within the driver node itself. Then standard mode is again for a single user, but higher load. Then the high concurrency is where you have huge workload and many concurrent users working on your application. So for now, I'm going ahead with standard, which is also the default mode. Then pool simply keeps those many instances on a standby, just to reduce the startup time. And I'm going to keep it as a default as none. Then we can also choose different Databricks versions from here. As of now, it has got this 8.3 beta normal, 8.3 beta for ML and GPU, and also the 8.3 beta for ML with CPU. And if you click on more as you scroll down, you will see all the available versions over here. And if your previous application or something that you're trying to migrate is on a particular version, you can choose it from here. For now, I'm going ahead with the current latest version of 8.2. And then we have these 2 autopilot options. Now, if you deselect this auto scaling option, the minimum and maximum worker nodes will go away, and we will have just the number of workers as the option. Then if you have a heavy workload, you can choose the auto scaling if you don't want to commit the worker nodes in the beginning itself. Because remember, it will start billing you for all the active nodes. For now, I'm going to deselect it. And then you also have this auto termination option, and you can specify the number of minutes of inactivity. So I'm going to leave it to this default value of 120 minutes, and I will most probably delete it immediately after I'm done recording some of these videos here. Then worker type is nothing but the virtual machine type. So it gives you various options of general purpose, memory, or CPU or GPU optimized. And you can see the full list over here. Also, the charges for Databricks nodes are in DBU or Databricks units. They're again based on the type of machine that you're using, but it also simplifies the pricing for all the software and hardware on it in terms of DBU. Typically, it is around 40 to 60 cents per DBU-hour, so it can be really expensive. I mean, imagine you have just one worker and one driver node, and together, if they consume 1.5 DBU, you will be billed almost $1 per hour. So for a medium-sized cluster of around 10 worker nodes, you can get billed almost $8 to $10 per hour. So be careful of your choices here, and also make sure you delete them immediately after you are done. Alright, so I have deselected the auto-scaling earlier, so then I'm going to provide just one worker node over here. And the driver type will also be same as the worker node type. Alright, so one worker and one driver node is what we will have. Then if you click on this advanced options link, you will see these various options to configure your Spark, add tags, logging, and init script options. You can also set your environmental variables from here. For now, I'm going to leave them to their default values. And now to create your cluster, simply hit this create cluster button. Give it some time, and while it starts provisioning these nodes, and also install all the basic software required by us. So let me pause the video here, and I will be back in a flash once the cluster is created. Wow, finally it is done, and it took me a little over 4 minutes to see this created. So on this screen, you see the same options using which we created it. If you want, you can click on this edit button here and change certain things. You can set the permissions using this button. If you want to clone this cluster and save some time, you can do that using the clone button. That is to create another cluster with same configuration. Then you can also restart it or terminate it or even delete it from here. Great. Next, as and when we create few notebooks and attach them to this cluster, you will see them under this notebooks tab over here. Then under libraries, you will see various libraries including the Azure ML SDK, scikit-learn, and others that we can install. And we will see that pretty soon in the next few lectures. For now, we have come to the end of this lecture of creating the Azure Databricks cluster. Once again, congratulations in case you have been doing it along with me. And as always, it's a pleasure to teach you. Thanks for watching. Welcome back. As part of this video, now let's proceed further and see some more exam objectives of DP100. And particularly how to link the Azure ML workspace with the Databricks workspace. So while working with these two, we will have to create an Azure ML workspace as well as the Databricks workspace. So make sure they both are in the same subscription. They can have different resource groups, but the subscription should be same. Not mandatory, but better to have. And then we will link them. You may also need to upload the adult income dataset that we have created and worked with in the previous lectures to the default data store. And then we will also create or may even upload a notebook in the Databricks. And from this notebook running on Databricks, we will then submit and experiment on the Azure ML workspace. And let me promise you, that will be some fun to see. And finally, we will view the results in the Azure ML workspace. And by this time, if you already have the Databricks cluster created, you can detach it or may even delete it for the time being to save some cost. So I have this Azure ML workspace created, and let me go to the datasets. And I have also created the adult income dataset over here. Great. The Databricks workspace is also created, and let me go to the workspace resource page in order to link it. Now, from this resource details page, if you scroll down a bit, you will see this tab to link it with the Azure ML workspace. So simply click on it. And now on this page, you need to provide the details of Azure ML workspace, which we want to link. So you can also create a new one here as a part of linking it, or even use an existing one. So let me select the resource group of my Azure ML workspace, which is this Azure ML SDK RG. And then in the workspace type, I'm going to select the option of use existing. It should automatically select the workspace in this particular group. And if there are more than one, you can choose it from this dropdown. Now, even though we have chosen an existing one, this button still says review and create. Don't worry about that. It is not going to create a new one. It will simply link it. So let me click on it. And as usual, it will do some validations. But this time it will be pretty quick because the workspace exists. And once it has passed all the validations, simply click on create button to create or link it. And I think this is work in progress for Azure team, and they may change this button description depending upon whether it is for new or an existing one. And even here, after pressing the create button, it won't take much time, and it should be done within a matter of a few seconds. And once you see this message, it simply means that the Databricks workspace is now linked to the Azure ML workspace. And if you want to verify it, let me go to home, and then let's go to this Databricks workspace resource. And here, now you will see the Azure ML workspace name right over here. Also, if you scroll down, the option to link the Azure ML workspace is no more there. So congratulations on learning how to link the Azure ML workspace to the Azure Databricks workspace. As always, it is a pleasure to teach you. Thank you so much for joining me here. Hello and welcome. And today, let's see how we can create and run a notebook on a Databricks cluster. Now, before we run a notebook, we may require some libraries installed on this Databricks cluster. And as we saw earlier, we can simply click on this tab for libraries inside the cluster. And here, for now, you won't see anything as we have installed nothing. So click on Install New, and it will open this dialog box where you can specify the installation library source as well as its type. Right now, I want to install the Azure ML SDK for Python that we used earlier. So click on PyPy and specify the Azure ML SDK package information. But remember, because we are going to install this on our Databricks cluster, we cannot use the typical package of 1.12 version. If you install this, some of the functions will not work correctly, and you may get errors while authentication, as well as while using some other functions as well. So for Databricks, we need to install this Azure ML-SDK, and without leaving any space within the square brackets, Databricks. And you can leave the repository blank for now. Alright? And then click on Install. Give it a couple of minutes, and then it should be done installing it. For now, I'm going to pause the video here and come back once it is done. Great, it is done installing for me. And now let's see how we can create and run a notebook on this cluster. If we want to create a new one, we can simply click on create and then notebook. Again, it will open a dialog box, and let me provide the name as test001. Then the language of the notebook, which is by default, I'm going to keep as Python, but you can also specify R, Scala, and all the others which are supported. Then you can attach it to a Databricks cluster, so specify that, and then click on create to create it. And there you go. It will be a very similar and a very familiar one, like any other notebook that you may have worked with. And to begin with, let me start with the same old hello world. So let me type print, and within parentheses, within the quotes, hello world. And here, if we want to run this cell, you need to hit the Shift plus Enter to run it. And it will submit the command. And there you go. You will see the hello world printed right over here. Great. But this is not what we want to do. We want to run a real experiment script on the Databricks. Now, if you remember, during some of the initial few lectures, we ran this experiment on our local machine. We even accessed the dataset from the AzureML workspace, loaded it in a pandas data frame, and then logged some metrics on the AzureML workspace. And let's now do the same in the Azure Databricks cluster using its notebook. All right? But in the interest of time, let me do that in the next lecture. As always, thank you so much for watching. Welcome back, and now let's run an experiment on this cluster and log the metrics in the AzureML workspace. And to save some time, I have already saved one notebook. It is also attached to as a resource for this lecture. So download it and save it on your machine. And to import, all we need to do is click on this workspace link. And in case you are not on this home directory, then click on this home, and you will see our home or user directory over here. Click on it, and it will provide you these options to create, clone, import, export, and so on. So click on import. And now it gives you a couple of options, such as import as a file or from the URL. Also, if you see here, we can import notebook in .dbc, Scala, .py, then the notebook format of IPYNB, as well as these other formats. Now, I have stored the file in a .dbc format, so simply click on this portion where it says drop file to upload or browse, and then upload this run notebook on Databricks cluster file. It should be done pretty quickly. It's a very small file, so click on import, and the file will be imported right over here. You can simply click on it to open it. Great. And then the first thing we need to do before we can run it is attach it to some cluster. So click here and attach it to this MyDB cluster over here. And without attaching it, we won't be able to run it. Great. And now make sure that you have the correct subscription ID, correct resource group, and the workspace name over here. Also, make sure that you have uploaded the adult income or the loan dataset to your default data store. You can use any dataset here as long as the file is uploaded. Then a dataset is created and it is registered. For now, I'm going to use the adult income dataset. All right. So let's run this first line of importing the workspace. So place the cursor inside this and simply hit Shift plus Enter. Or you can even run it from this run or play button that you see here. Now, it is very much likely that you may get this error in the beginning that says failure while loading the AzureML runtime provider and blah, blah, blah. Simply ignore that. I think this is some sort of an issue that Azure needs to resolve when we run just the AzureML SDK without AutoML. Anyway, simply run it again and it will go fine. Then let's also run this second cell for now. And here it will ask you to authenticate yourself. This is very similar to the authentication prompt that you got on your local machine when we first tried to access the AzureML workspace, or for that matter, any object of that workspace. So in this case, simply copy this URL that ends with device login, and then paste it in a new browser tab, and then hit enter, and you will be prompted to enter some code here. So let me go back to the Databricks tab, and here we have that code which is required for authentication. So copy it, and let me come back to this device login tab and paste it there, and then click on next. Then in the next screen, it will ask you to pick up your account. Simply select it and then let it do the authentication. Now, if you come back to the Databricks tab, you will now see a message here that says your authentication is complete. Great. And then the next few cells are pretty straightforward. We access the data, create a new experiment, and even start logging it, which, as you must know by now, will create a new experiment run on the AzureML workspace. Then we also have this code to read the data, get the total number of observations, as well as creating the null values and finally logging them. So what I'm going to do is instead of running them one by one, I can click here and then run all below to run them in one go. And wait for a few seconds and it should be done pretty quickly. It doesn't give us any error and that means it went fine. So let's go to the AzureML workspace and see what has happened there. And now let me click on experiments. And there you go. We have this new demo experiment created over here. Click on this latest run. It is completed, means it is done successfully. And as you can see, it has got all these metrics of the number of values, null values in these columns. It was 0, so no problem there, but at least it logged that. And if you scroll down, you will also see these total observations of 2000 logged over here. And if you have been doing it along with me, congratulations on learning how to create and run the notebook or the experiment script on Databricks cluster. We not only ran a notebook, but we also made it interact with the AzureML workspace. Great. And with that, we have come to the end of this lecture. And in case you plan to take a long break, please don't forget to delete your resource groups for Databricks as well as the workspace. Or at least delete any virtual machines or these Databricks clusters before you take a break. And as you know, as always, it's a pleasure to teach you. Thank you so much for joining me here. Hello and welcome. And now before we move on and see how to run various experiments on Databricks, it is very important to know how to access the data from the Databricks cluster. So let's see that now. And for this, I have already created a storage account by the name JLK Storage 001 and also created the container by the name JLK Container 001 inside this storage. Then I have also uploaded the adult income truncated data as a CSV file. And I also have this Databricks workspace and created a cluster for it. By now, you know how to do these things. So let's now see how we can access or mount the blob data to this workspace. For that, let me open a new tab and search for Azure Blob Databricks. And the first link that you see is from the Databricks documentation. And you can open that or this Microsoft link, which should be among the top 3. I'm going to open the Microsoft one. They are actually very identical, but in case there is any change, there is a higher likelihood that Microsoft link may get updated quickly. And you can read through the documentation, but let me scroll down, and I am interested in this section of Mount an Azure Blob Storage Container. So it gives you both the Python as well as Scala code. There is not much difference here, but because we are using Python, let me copy that code. And then come back to the Databricks workspace, and let's now create a new notebook. And let me provide the name to it as blob mount 001. Attach it to the cluster and hit enter or create. Great. And now let me paste the code that we copied in this first cell. Many online documentation that will suggest you to create a PySpark session, but that is not mandatory here. All right. And now let's see what changes are required in this script. So first is this container name. So let me provide that as JLK Container 001. All right. And then after this at symbol, it expects us to provide the storage account name. So let me type that as JLK Storage 001. Make sure you remove these angular brackets also and don't delete any other extra character. And in case you copy and paste it, you may get an extra space here. So make sure you avoid those simple and silly mistakes. Great. Then it expects a mount point where this data will be mounted. Now mount point is similar to the directory or folder. And once we create this mount, we can then access the files at that mount as if it is a local directory. But I want to tell you one thing, that it does not create a copy of the data. It simply creates a pointer and the data is always stored in the blob container. Also, if we give a particular path as part of the mount, it may not check whether the directory or the blob particularly exists or not. It will simply make the connection to the container and then create a pointer. And in case you are using a paid account, make sure that the Databricks as well as the storage is created in the same region. Otherwise, you may get billed for the data movement across the region. Okay, so now let me provide the mount name as AI data, AI for adult income, which is what we stored in the container. Great. Next, we need to provide these extra configuration options, and this can be a bit tricky at times. First is this conf key or configuration key. And now let me go back to the documentation once again. And then scroll down a bit. And right here is the description of what it expects for the conf key. Now there are two options here depending upon whether you used SAS authentication or normal storage account key-based authentication. I have used account key, so let me select this grayed out code starting from this FS all the way up to windows.net. Make sure you copy it, come back to the notebook and carefully select this conf key along with the angular brackets and then paste it on top of it. Basically, just replace this particular part of the code. Great. Then inside that, we need to replace this storage account with JLK Storage 001. Then after the colon, it has this code to get the secret key based on the scope stored in the Databricks workspace. Now, if you are interested in knowing what is this scope, you can go back to the documentation and then open this secret scope link that you see here in our new tab and you can go through it. But in a nutshell, fundamentally, it is nothing but a collection of secrets or secret keys. So you can store all the access or security keys in a scope with some key name. And later on, you can simply access the key value using the scope and the key name. And that way, it simply makes it very secured and you won't expose it to others. All right. And let me go back to the notebook now. And I'm not using this scope here. And the storage account will be deleted after this video. So I'm not worried about it for now. So let me delete this code starting from dbutils all the way up to key equals 2. And also delete this extra parenthesis, which it has already marked as an error. And now we need to provide just the key name inside these quotes. So let me go back to the storage account. Click on these access keys for the storage account. And then show keys and copy any of these two keys. All right. And now let's go back and paste it inside the double quotes instead of the key name and these angular brackets. Now, please be very careful with it when you are pasting these keys and removing these quotes, these angular brackets and stuff like that. Great. Now, I'm doing everything right inside this code and it is looking pretty messy. So instead of this, you can also create string variables for these different strings and then provide them as parameters right inside this mount function. So let me pause the video and quickly do that so that it is easy and a very readable code. So we have source, mount underscore point, conf underscore key, and the key underscore name as the string variables. And these variables are passed as parameters to this mount function. Great. And we are now ready to run this code and access the adult income files. So let me run these variable cells first, and it should go fine. And then run this cell with mount function. It will take a few seconds as it submits a Spark job. So remember, every line of Python code is submitted as a command, but majority of these dbutils functions or Spark functions will trigger a Spark job. So let it run for a few seconds and it should be fine. Wow, it is done for me, and let's now check whether we really have the access to this data. So for now, we have just established the connection to the blob container. And next time when we read it, we will have the access to that data. But in the interest of time, please allow me to do that in the next lecture. Thanks for watching. Welcome back, and let's now read this data using pandas. And for that, let me first import it as import pandas as pd, and run it using Shift plus Enter. You don't have to install pandas here. By default, it is provided along with some basic packages of Python. Next, let's read it in our data frame as df equals to pd dot read underscore csv. And within parentheses, let's now provide the path to the file. Now remember, we have the directory created as mnt/ai data. So provide that in double quotes. And this is just the location of the file. So after AI data, provide a slash and the file name as adult income as one word, space, trunk.csv. Now, if you try to run this as it is, it will give you an error of no such file or directory. But a similar code using spark.read.text instead of pd.read underscore csv will work. And that is because the way the path has been provided. So the solution for pandas is pretty simple. All you need to do is provide the absolute path using dbfs. So just before this mnt, add a slash dbfs slash. That's it. Here, dbfs is the Databricks file system and is mounted on the root directory. So let me run this cell now. It should go fine, but it may take a couple of seconds as it needs to connect and fetch the data from the blob storage. Great, it went fine and has also read the data. But as they say, the proof of the pudding is in eating it. So let's print this df and see its content. So simply type print and df within the parentheses and hit Shift plus Enter to execute it. And there you go, all our data is now printed right over here. Of course, it is truncated on rows as well as columns, but that is how it prints thousands of rows and columns. And I hope now you know how to mount the data as well as read it using pandas. And before we end this lecture and start celebrating, let me also show you a small best practice while mounting any storage. And some of you who are familiar with SQL would know that we always delete a table before creating it. And similarly, you should always unmount a mount point before mounting it. So for that, all you need to do is create a cell before this mount and use the unmount function. But this time, you should use the try except block, because if it is not mounted and we try to unmount it, it will give you an error. So simply type try colon and hit enter, followed by dbutils dot fs dot unmount, and within parentheses, provide the mount point. Hit enter again, and below that, type except, followed by colon. Make sure that except is indented with try. Hit enter again, and print, within parentheses and quotes, the mount did not exist. So for the beginners in Python, this is simply going to try executing this unmount statement, and if there is any error, it will execute this except statement. And because of that, you won't face any termination of the code in case it gets an error. Just one of those many best practices, and not at all difficult to understand. I hope this is fine, and now hit Shift plus Enter to execute it. So if the mount point exists, it will execute this statement using a Spark job. But if it does not, it will treat this print statement as a command and will run that. Wow. And with that, we have come to the end of this lecture. And before we end it, please allow me to summarize what we learned in the last couple of lectures. So we copied and pasted the relevant code from the documentation. Then we added our container name and the storage account name. We also provided the mount point, which acts as a directory, but is a pointer. Then as part of these extra configuration requirements, we again provided this configuration key with this storage account. We then copied the access key from the storage account and provided that as the key. With all that set up, we then ran the mount function of the dbutils, which mounted this container to this mount point. And finally, we proved the data access using the very familiar pandas read CSV function. Great, and this is usually the first and the most critical of all the steps in an experiment. And once we have the data with us, it is very easy to execute any Python code that can work with the data. So let's now go ahead and do some model training and such stuff in the next lecture. As always, I'm so happy to teach you right from the basics to advanced. Thanks for joining me here. Welcome back. And now that we know how to attach the data to the Databricks workspace, as well as read it using pandas, let's see how we can run an experiment on this cluster. It is pretty easy and very similar to how we run an experiment on any computer. But first, we have to make sure that we have the required libraries installed on this cluster. And as you know, the most frequently used one is the scikit-learn. So first, let me open this cluster in a new tab. Click on this cluster name. And then libraries. Now, this is a new cluster that I have created, and that's why we don't see any library installed on it. So click on install new, and then under pypy, provide scikit-learn. Now, if you want to specify any particular version, you can do that using double equal to sign followed by the version number. For now, I'm going ahead with the latest one, and click on install. Give it a couple of minutes while it installs it. So I simply paused the video while it was installing it. So now it is successfully installed. Let's now go back to the Databricks notebook. So I simply paused the video and added these lines. And as you can see, they are pretty simple and straightforward also. And we have done them numerous times. So we create the dummy variables, create a new data frame of data prep, then create X and Y, split it, import the random forest classifier, train the classifier, predict the results from the test data, and finally create the confusion matrix and the accuracy score. And we are finally printing the confusion matrix and the score. And if you want, you can run them one by one, or simply go to this cell where we import pandas and click on this run icon. And then to run all the cells from here, click on run all below. It will be pretty fast in running it, and very soon you will see the confusion matrix and the accuracy score printed over here. Wow, and if you have been doing it along with me, congratulations on running your first training experiment on a Databricks cluster using the data from Azure Blob Container. As I told you, it is not different than running it on any other computer once we have all the libraries installed and data is mounted to DBFS. Now the question is, how is it different than running this experiment on any other normal machine? Well, even though we are not using the core MLlib of Spark, we get to benefit hugely from the in-memory and the parallel distributed computing of Spark. In many cases, and in particularly when we are using the cross-validation or hyperparameter tuning, as well as automated ML, it can help do the training much quickly. Now, during cross-validation, it creates different sets of train and test data, and then runs the training models those many times. And I'm sure now you can understand that these multiple jobs can be executed very quickly using Databricks. And similar to cross-validation during hyperparameter tuning, we create multiple combinations of parameters and then train the model on all those combinations. Once again, the Databricks parallel processing can help us there as well. And I'm sure you have gone through the automated ML lectures. And you will know that it submits multiple runs for multiple models with multiple combinations of hyperparameters. Again, it can be done very quickly using Databricks. Alright? But now, and as always, you must have guessed some twist in the story based on this but. Well, of course there is. So this is executing scripts and the experiments on a standalone Databricks workspace. Even the earlier experiment that we ran using Azure ML SDK was also done from Databricks. Now, what if we can make use of the best of everything? And what I mean by that is, what if we use Databricks for all its benefits of faster data processing and then use the local computer for saving some development cost? And that also provides us some ease of use. And then we also use the pipeline capabilities, logging, dashboarding, and others of Azure ML service. Well, that will be a very flexible and very powerful combinations with best of everything. So what are we waiting for? Well, let's do that in the next series of lectures. And it is going to be super exciting and fun. As always, it's completely my pleasure to teach you. Thanks for watching and have fun. Welcome back, and let's now see how we can do a full integration of Databricks, Azure ML, local development, as well as the data storage. I hope you remember this code that we ran in one of the previous lectures on pipelines. We had these different steps with various parameters, and we finally built a pipeline from these steps and ran it as an experiment. Now, if I have to show this visually, this is how it can be presented. So we kept the data in the storage container. Then this data was used as a dataset using this data store inside the Azure ML workspace. The input dataset was then consumed by the first step for further processing. And it was also storing the output as a data folder using the pipeline data. Now, this pipeline data was further used by the second step using the same reference of the data folder. And the input data and the pipeline data were all passed as data references and parameters to these steps. We then created an Azure ML cluster which then takes these pipelines and run them as experiment run inside it. Alright, and I hope that's a good enough recap and a visual presentation. But this was all inside the Azure ML workspace. And now we want to use the Azure Databricks for one of these steps. And this can be achieved using the Azure ML class called as Databricks step. And we will see the details including its parameter later on. But its working is more or less same as a Python script step with some minor changes. But remember, it still needs to read the input data and accept the dataset reference as an input parameter. And that basically means wherever or whichever cluster it is running on, it first needs to authenticate itself with the Azure ML workspace. Then it also needs to save the output as a pipeline data. And this second step needs to accept that as an input using this pipeline data reference. That also means this Databricks step or its cluster needs some authentication with the storage account. Earlier, it was handled by the Azure ML workspace and its data store. And as you know, data store is nothing but a secured access connection to the actual data. Same is the case with pipeline data. It's also a data reference. I hope it is clear up to this point. And now, from here, let's create the steps required to complete an experiment, which will use the Databricks steps as one of the pipeline steps. Now, all these steps, I have divided them into 3 categories. The usual setup steps, then the Python job steps, and finally the Databricks notebook steps. So let's first see these 2. So setup steps are very typical, and we all have done them numerous times. But I have still listed them down for completeness. And you can also use them as your checklist or maybe a template whenever you are working in your projects. So the first is, of course, creating the storage container and then storing the data in that container. And at various times, you will also need the access keys to communicate and authenticate. So keep it handy. Then, of course, the Azure ML workspace, its data store and the dataset. All right. Then next, we need to create the Databricks workspace, its cluster, and also copy the access key to the workspace. So far, we have not seen how to generate this key, and we will see that in one of the lectures going forward. So it's a pretty simple and straightforward stuff, nothing to worry. Then as part of the Python job steps, same old standard stuff to begin with. So we access and create the workspace object from the config file. Then we create our custom environment as well as the cluster for the Python script. We also create the run configuration that will be used as part of the Python script step using the environment and the cluster. And finally, we will create the data reference for the input data and the pipeline data reference for the output data. And I think we have not used this data reference class so far. It's pretty simple, and we will see that as well. Then, if you remember, we used to attach the local compute or the compute cluster as the target machine for running the experiment. In case of pipeline, it's always the compute cluster. Then, when we want to run one of the steps on Databricks cluster, we need to attach it as a compute target to the Azure ML workspace. So, as part of it, we need to provide some configuration parameters, such as the resource group, its name, as well as the Databricks authentication key. And by this time, we would be more or less done. And after that, all we need to do is configure the actual steps. So, the experiment that I'm going to show will have just 2 steps. One for Databricks and another for normal Python script. So we need to create that as well. So we have seen the Python script step, and you will also learn the Databricks step. And once that is done, then it's a matter of simply building the pipeline, submitting it as an experiment run, and then finally viewing the results. It's not a rocket science, and if you have done the previous lectures on pipeline, you will not face any problem whatsoever in understanding these steps. Then next, we need to build a Databricks notebook, which we are going to run as part of the Databricks step. Once again, the steps are pretty sequential and simple. So first, we unmount the mount point, similar to what we saw earlier. Then we get input and output data references as the parameters. Then when we are dealing with pure Python programs, we were using the args parsers to collect the arguments. So all these data references, we were collecting them as part of that. Now, when we are dealing with the Databricks cluster, we need to use the Databricks utilities for collecting those arguments. So we will use this specific function of get within the dbutils.widgets. Do not worry, because before we start using them in the final program, I'm going to show you how it is done in a very simple manner. Alright, so you are very well taken care of. Then some of the next steps are pretty straightforward. So we are simply reading the data from the Azure storage using the mount point, then perform whatever data processing we need to do, or building the model and such. Then we save it in the Azure storage using the same mount point. But here, there is some small hack or trick that we will have to use to save it without any issues. Particularly because we are using the blob storage. And I will show you all such tricks and hacks that will be required to successfully execute these experiments. Wow, and that is one hell of a task and so many steps involved. And if you try to learn this elsewhere using some online documentation or such, you will not find such a detailed execution of these steps and everything being done together. Now, what happens is most of the time, these services and these resources work in isolation perfectly. But when we try to combine or integrate many services, we start facing some challenges. But not in this class. I'm going to smoothen your journey and teach you all the hacks and tricks as we go along. So let's go ahead and complete these steps one by one. As always, I'm so happy and excited to teach you. Thank you so much for joining me here and have fun. Welcome back. In one of the previous lectures, we saw how to read the data from the blob store. And today, let's see how to write it. Now, you may wonder what's the big deal. We can simply write it using the same write method or the function and then use the same path on the blob container. That should suffice, right? But actually, no. And let me explain that by doing it. So I have already created this storage account container and mounted it as AI data. And we saw that in one of the previous lectures as well. I also ran this code just now to save some time. And now let's try to write some file to a folder in the blob storage. For that, I'm going to use the to_CSV method of the data frame. So that will be df.to_CSV and within parentheses and quotes /dbfs/mnt/AI data/ and let's store the output in our folder called data folder followed by a slash and let's call this file as adult test.csv. Alright, looks pretty neat and clean. So let me hit Shift plus Enter and see what happens here. It says the folder or the directory does not exist. And we know that. There is no folder by the name data folder in this container. And that's why we got this error. So some may say let's use the Sparks CSV write function. So let me try that and show it to you. So I'm simply going to copy and paste the code for that. All right. So what is happening here is you first convert the pandas data frame to Spark data frame, and then use the write.csv to write it to this particular path. And the more overwrite means the file will be overwritten if it exists. And just to keep it simple, I'm writing it to this folder called Spark folder, and the file name is adult.spark.csv. Even this folder does not exist. So let me run this cell and then see what happens. And wait for a few seconds if it is taking some time. And wow, this one has gone well, even though the Spark folder didn't exist. So then it is very normal and natural to think that we should just use this. But hang on a second. Let's first go to the storage container and see what has been written there. And now refresh it if you are already there in the container. And we indeed have a folder now by the name Spark folder. We also have this empty blob here. But first, let's go to this folder and see what's inside it. So we have this empty CSV file and a folder by the same name. So click on this folder. And there you go. We have so many files written over here. And if we click on one of these starting with part and this number, and then click on edit to see the data. So we do see some data here. And if you scroll all the way down, you will see that it has written some 500 records over here. And if you want, you can check the other partitions as well. And they will also have a part of the data from the original file. So what is happening here is the Spark is executing multiple tasks for this job of writing the file. Okay? And then each of those tasks are writing their own partition files. And that's why we see more than one file over here. And if we need to write one file, we need to write some additional code in our program. Because if we need to pass on this as a reference to output data for another pipeline step, it will be slightly difficult to read it. And in many cases, we won't be able to get to the exact one file that we want. So what should we do if we still want to use pandas? Because that's kind of a de facto standard for data processing in majority of the existing code. And if you're trying to bring in your current code on the Databricks, you may want to do minimal changes to it. Well, in that case, we will have to create a directory before we can use the toCSV method. That's the only solution as it appears as of now. So for that, we can use the dbutils make directory function and create a blob and directory. So let me just add a cell before this to_CSV. And let me type dbutils.fs.mkdirs, the short form of make directories. Very similar to the command we use in other operating systems as well. And then inside the parenthesis and quotes, let's provide the directory path as /mnt/AI data. So this one would begin with MNT because this is part of the dbutils. So it doesn't require the absolute path starting from dbfs. So now this will point to the container. And that's why we need to provide another slash followed by the directory name of data folder as one word. And please do not execute it just yet. Now, if we simply execute this, we will create a blob by the name data folder and not a folder by that name. Because blob storage cannot create an empty folder. It has to have some blob. So I'm simply going to add /000 and then hit Shift plus Enter to execute it. Give it some time and it should go fine. And now if we go to the container and refresh it in case you haven't, you will see this data folder created right over here. So click on it. And there we have the blob 000 with no data. But our objective of creating a folder is also very much achieved. So let me go back to the code and now let's run the cell with to_CSV in it. It went fine and let's check our container now and refresh it as well. And there you go. Now it has written one single file for adult income in this folder of data folder. Great. And now the only reason we had to do this is because the to_CSV does not create a directory. Then Spark's write.csv does not write it as one file. And on top of that, blob storage does not create an empty directory. Now, if you do not know these three very subtle differences and cannot make them work together, let me tell you, you would struggle for a long time trying to figure out why certain things are not working the way they should. Now, I could have just shown this and explained to you verbally in just a few seconds, but then you would not have got this chance of experiencing what is happening here. My aim is not just to prepare you for the exam objectives, but also to make sure some of the practical knowledge is also passed on. I hope you like it. So now, let me end the lecture here, and I will see you with another concept required for running an experiment using Databricks cluster. As always, it's my pleasure to teach you. Thank you so much for joining me here. Hello and welcome back. Now, before we start working in an integrated manner, we should know how the parameters are passed, received, and used in the Databricks notebooks. As part of this integration, we will be passing the data references for the input as well as the pipeline data. And when we pass the data references, it is basically the absolute path of the data that is sent across. Our entire integrated application will work only if we are able to communicate successfully with these different resources. It's simple, but very important to know them. So let's go ahead and see it. So here I am in the Databricks workspace, and I also have a cluster created. So now let me first create a new notebook as NB001. Attach it to the cluster and hit create. And there we go. And now if we need to run a notebook from this one, we can simply use the %run command. So let me type %run followed by a space and provide the notebook path over here. So we can provide the relative path as dot slash, and let me call this new notebook as nb002. So if you are not passing any parameter, this will simply execute this nb002 and provide us the result over here. Then if we want to pass the parameter, all we need to do is simply type them as $sign, and this sign basically denotes that this is a parameter. Then the parameter name, and let me provide that as p1 equals to, and let's give some value in quotes as hello. So that basically defines this parameter p1. And if you want to provide another parameter, simply type the $sign, parameter name, and then value. For now, I'm just going ahead with p1. It's pretty simple, isn't it? So now in another window, let me create this notebook as nb002 and attach it to the cluster. And now to accept a parameter, we need to use one of the dbutils function as dbutils dot widgets, and it's a plural form for both of them, dot get, and within parentheses and quotes provide the parameter name as p1. So this will fetch the parameter value, and we can even assign this to a variable as p1 equals to, and this entire statement. Now just to prove the point, let me print a statement as print, and within parentheses and quotes inside nb002 comma p1. All right. And now let's go back to the nb001 and then hit shift plus enter to execute this cell. It should be done pretty quickly. And there you go. It has successfully run this notebook nb002, collected the parameters, and even printed it. So when we are running our own Python programs and Databricks steps, we may not need this %run command syntax. That will be taken care of by the Databricks step in AzureML. But we will surely require this part of the code. Great. And now, with all these concepts covered, it will now be super easy to understand the actual work of running an experiment on the Databricks cluster using local machine and from the AzureML workspace. Some super exciting stuff is awaiting for you in the next few lectures. As always, it's completely my pleasure to teach you. Thank you so much for watching. Welcome back. And now in this lecture, let's see how to attach this Databricks cluster to the AzureML workspace. And then we will use this cluster for running the notebooks as part of our pipeline. For that, I'm going to use this local machine and attach it. In the same manner, we created and attached the compute cluster. So here I have already imported the workspace class and also creating the workspace from the configuration file. Then attaching the Databricks cluster to this workspace is again a two-step process. First, we need to provide the configuration information of the cluster, and then we attach it with that configuration. For creating the configuration, I'm going to use a class called Databricks Compute. So let's import that right at the beginning as from azureml.core.compute import Databricks Compute as one word with D and C capital. All right. So let me first run this line, and then we will see one of the methods of this class that we are going to use. And it should go fine. So let me open this class and also maximize it. And now if you scroll down here and click on this method called as attach_configuration, you will see this description. It's a very simple method and takes just 4 parameters of a resource group of the Databricks workspace in which the Databricks cluster is located. We also need to provide the Databricks workspace name, and then finally we need to provide the resource ID and the access token. The resource ID is very much optional. We can simply provide the workspace name along with the token, and that should be sufficient to get the access. So let's go ahead and create these parameters. And let me call the resource group variable as db for Databricks _resource _group equals to, and now in quotes the resource group name, which in our case is Databricks RG001. Next, the Databricks workspace name as db _workspace _name equals to, and in quotes Databricks WS001. And finally, the db _access _token, and that is equal to, and now let's create the access token for our Databricks workspace. For that, let's go back to the workspace. And from here, in this top right corner, click where you see the workspace name, and inside that, the user settings. And here you will see the option to generate the new access token. Click on it. So you can specify some comments here and the validity of the access token. For now, let me just say testing in comments. And when you're working with the production environment, you can specify the lifetime as per your organization policy. For now, I'm just leaving it to 90 days. I may not even keep it for 9 hours because we will be deleting it very soon after this exercise is completed. Anyway, and now click on generate. Now it will generate this token, but you have to copy it right now before you hit done, because you won't be able to see this token again. So let me copy it and click on done. And now that we have this access token, let me come back to the code. And within quotes, paste the access token. Great. So this is enough to connect to the workspace. Now, as we do every time we create a cluster, let me check whether a cluster or the compute name exists in our AzureML workspace. So that will be if db _compute _name not in ws dot compute _targets and a colon. So let's declare and initialize this compute name variable also as db _compute _name equals to, and give the same name as the db cluster name of my db cluster 001. Great. Now inside this if, let's create the configuration object as attach underscore config equals to, and now the class of Databricks compute will come into picture. So type that as Databricks compute as one word dot the method of attach underscore configuration, and inside the parenthesis first resource underscore group equals to db underscore resource underscore group, comma, and then in the next line workspace underscore name equals to db underscore workspace underscore name, comma again, and finally the access underscore token equals to db underscore access underscore token. Great. And now to attach the cluster to the Azure ML workspace, we need to use another class. And let me first import it at the top from the same core.compute. So a comma after Databricks compute and type compute target as one word with C and T capital. Now using this class is very simple. And we will use the attach method of this class to attach the Databricks cluster to the Azure ML workspace. And it returns an object. So let's collect it in a variable as db underscore cluster equals to compute target, this class, dot attach, and within parentheses provide ws for the workspace, comma, and then the Databricks cluster name as db underscore compute underscore name, another comma, and now the configuration of it, which is stored in this attach underscore config. That's it. And let's also make it wait until this operation is completed. So that will be db underscore cluster dot wait underscore for underscore completion, and in brackets true for show output. Just true is enough. And in case it exists, we need to still create this db cluster object, because this one is simply going to provide whether it exists or not. So that goes in the else part of this if as else and colon, then the next line db underscore cluster equals to ws dot compute underscore targets, and within square brackets db underscore compute underscore name. And if you want, you can add a few print statements here before these lines. So for now, I'm going ahead and let me select all the lines and hit Ctrl plus Enter to execute them. So this one has not been attached to our workspace, I mean the Azure ML workspace, so of course it won't find it there, and it will continue with the attachment. Give it some time, and it may even take a few minutes to attach it, but hopefully it should be done successfully. So I'm going to end this lecture here, and in the next one, let's just verify how this run went and whether the cluster has been attached or not. As always, thank you so much for watching. Welcome back, and the script has finished successfully, and it says the operation succeeded. That is great. And let's now verify it on the Azure ML workspace. So let's go there. So here, click on this compute link, and then on this attached compute over here. And there you go, we have our Databricks cluster attached over here. Remember, this is not a new cluster. It's the same cluster that we created in our Databricks workspace. Click on it to view its details, and it will show you its type, its name, as well as the Databricks workspace name. Great. And now, if you want to create or attach it using the Studio interface, you can simply click on this new, click on Azure Databricks, and then simply provide these three details of compute name, Databricks workspace, which you may have to select from this Databricks workspace, and also provide the Databricks access token. And once you do that, simply click on attach, and it will take care of everything. Very simple. For now, I'm going to leave this page, and if you have been doing it along with me, congratulations on attaching the Databricks compute to your Azure ML workspace. Thanks for watching. Hello and welcome. Now with all the minor details completed and understood, we are now ready to run the full pipeline using Databricks step. So let me walk you through what I have done here. These are all different pieces that I have put together. So I have the data storage and the blob container created and the CSV file uploaded over here. I have also copied the access keys for the storage account. Then I have created the Azure ML workspace, created a data store by the name Adel Tinkham, and also created a dataset by the same name. Great. Then I also have this Databricks workspace created, one Databricks cluster provisioned, and also copied the access token. Alright, great. Now make sure you have done all of this and keep the names of the resource group, workspaces, cluster names, storage account, container names, as well as various access keys handy. And let's now see the code to run the pipeline on Databricks cluster as well as the Azure ML compute cluster. As I said, we have done coding for more than 90% of this code, and I'm simply putting different pieces together. So I'm simply going to walk you through some of the code, but we will surely code and I will also explain everything that is required. So we get the workspace, then we create and register the environment, and these are exact same steps that we have done earlier also. Then apart from scikit-learn, I have also added joblib here because we would need it for serialization of the model. Then we are also creating this pipeline cluster where our Python script will run. Then as you know, we cannot run a pipeline on a local compute. So this also we have done in the past. And I have simply copied and pasted this code with some minor changes, such as joblib, comments, or the names, etc. Then we create this run configuration object, which we need to pass to the Python script step. Again, no changes here. Then we also attach this compute cluster to the Azure ML workspace. We did it in the previous couple of lectures, and once again, I have simply copied and pasted the code related to the Databricks part. Now, when you copy, make sure the variable names, the parameter values, and these keys and such things are very much valid for this code. Great. Then I have also run this part of the code, and then I have this data reference and pipeline data objects getting created right over here. So I have imported these classes, pipeline data from pipeline.core, and the data reference from data.data_reference. We have seen the pipeline data in one of the previous lectures, and as you know, it is nothing but the reference to the data storage, which in our case is the blob container by the name JLK container 001, where the adult income file is stored. Now, if you observe this data reference class and its parameters, they are pretty much same as pipeline data. So we have the data store name as this adult income data store, and we also give some reference name to it. We are simply calling it input over here. Then, in case of pipeline data, we have the same data store and the reference name of output over here. So why do we need both of them? Well, actually, you don't. Even if this input data is created using pipeline data class, it won't make any difference whatsoever. First, let me run these lines from this import up to output data 1. In case you have not done that, please do it. And now let me just print input data on the console over here. And also do the same for output_data. You simply need to type them and hit enter. And as you can see, they both are objects of type data reference with this reference name added to them. You can even verify that from the variable explorer. So what is happening is, as the Azure ML as a service evolves, many of these classes are getting recreated with different names with some modifications. And it is also very much possible that one of them will be deprecated in the future. So there is no harm in knowing both of them. Alright, so hopefully you are good until this particular point. And next, let's create the steps for our pipeline with Databricks steps class. So please allow me to do that in the next lecture. Thanks for watching. Welcome back, and now let's create our Databricks step. So first we need to import its class as from azureml dot pipeline dot steps import Databricks step as one word and the D and S capital. Okay, and you can run this line and go through various parameters of this class or even search for it in the AzureML documentation, and you will get the complete details of it. For now, let's start coding it, and then as I add the parameters, I will explain them to you. So let's create the step as db_step01 equals to this class of Databricks step, and within parentheses, first the name of the step that will be used inside the experiment. So that will be name equals to, and within quotes, let's call it by the same name as db_step01. Comma, and similar to other pipeline steps, we still need to provide the inputs and outputs parameters. So that will be inputs equals to, and once again, this will be a list. So within the square brackets, the only input that we have as input_data. Here we are passing the entire data reference and not as the named input, because currently we cannot get the run context inside the Databricks notebook. I hope you remember we used to get the run context, and from there we could extract the workspace names, dataset names, and such. But as of now, it is not available when running the Databricks notebooks. So another comma, and then outputs equals to, in square brackets, output_data1. Great. Now, as part of this step creation, we can even specify how many worker nodes will be used for this step. Remember, the cluster could be a large cluster, and we do not want to spread out the tasks unnecessarily. So there are two ways we can specify that. Let me code the first method of specifying it as num_workers equals to, for now, I'm going to specify just one, because we also have just one worker node for our DB cluster. If you have a large cluster with auto-scaling, you can even specify the minimum workers and the maximum workers for the Databricks step. But you can only specify either this num_workers or the combination of min and max. You cannot specify both. Okay? Then similar to the Python script step, we need to provide the path of the notebook or the script that we want to run. So that is notebook_path equals to, and I'm going to specify that in a variable by the same name as notebook_path. And before we forget, let's declare and initialize it before this step as notebook_path equals to, and within quotes. Now, to get this path, we need to go back to the Databricks workspace where we have kept it. Now, I have already coded it and also attached it to the cluster. So let's go there. Now here, from this cluster details page, you can click on this notebooks tab, and I'm calling this notebook as demo001. You can call it whatever you want, and right here, you will see the path of this notebook. So simply select this path and copy it, and let me go back to our code, and let me paste it inside these quotes. If you have not done it, just leave it blank for now, and once you have completed the notebook on Databricks, then you can add that path. Also, as I always recommend for such file paths, make sure this string is a raw string by adding an R before these quotes. Otherwise, it could give you an error if there is any Unicode character over there. Okay? Then we also need to specify the run_name, And this is the name of the job that will be run in the Databricks. So that will be run underscore name equals to, and in quotes, specify the job name. And if you want, you can fetch the details of the job using this particular name. So let me call it as db underscore notebook underscore demo, followed by a comma. And next, we need to specify the compute target on which this step will run. Remember, this step is being executed as part of an Azure ML experiments pipeline run. There is also a possibility that we may have multiple Databricks clusters attached to the Azure ML workspace. So we mention the specific one as compute underscore target equals to db underscore cluster. Remember, this is the cluster that we attach to our workspace. Now, in this script, we are doing everything at one place. I mean, in this one Python script. But it is very much possible that someone else may create and attach it, and you are simply using it. Okay? And once this is done, then we need to specify if we need to install any particular packages on this cluster as part of running this notebook. And that can be done using a class called as a PyPy library, specifically created for the Databricks and Azure ML integration. So let me import that first as from Azure ML dot core dot Databricks import PyPy library with both the P's and the L capital. All right. Now, to specify the packages using this class, we first need to create an object of it with the specific package names. So, for example, if we want to install scikit-learn on the Databricks cluster as part of this Databricks step, we can create an object first as scikit underscore learn. You can give any name you want, and this will be equal to this class of PyPy library. And then within brackets, we need to specify two parameters of package and the repository. So that will be package and the name of the package as scikit-learn. All right. And this is sufficient because repository is optional. So I'm not going to specify that over here. Then we also need another package of joblib. So let me create an object for it as joblib equals to, and again, the same class of PyPy library. And within brackets, package equals to, and in quotes, joblib. Now here I'm specifying these names, but I would recommend you to add an underscore or maybe give some, specific name, just so that it doesn't conflict in case you have those joblib or scikit-learn libraries imported over here, and you are using them in different ways with the same name. And now to install these packages on our DB cluster as part of running this Databricks step, we need to specify a parameter of this step as PyPy underscore libraries equal to, and a list of packages inside the square brackets. And now let's specify these two objects here as scikit underscore learn, a comma, followed by joblib. All right. And I hope it is clear how we are building this Databricks step. And slowly and gradually, we have moved towards its completion. Now, the last parameter that I want to specify for this step is allow underscore reuse equals to false with a capital F. Now, this parameter, when we set it to false, will not use the results or anything from the previous run. And if you keep it to true, everything that has run successfully will be used in this pipeline run also. Now, when we are testing this step for the first time, and to make it perfect, you may even want to run it in multiple ways using different trial and error methods. In such scenarios, I usually prefer to keep this as false. Great. And that completes, at least at a very basic level, the configuration of the Databricks step. If you go to the official documentation of this class, it's very easy to get confused with tons of parameters and a very detailed description of each of them. And it's also very easy to get lost in the documentation. But now I'm sure you know the most important parameters and how to code them. So in the next lecture, let's see the actual script that we are going to run on Databricks as well as on the compute cluster of Azure ML. As always, it's a pleasure to teach you. Thanks for watching. Welcome back, and let's now see the actual notebook and the script that we are going to run as part of this pipeline. I have opened it over here, and trust me, if you have gone through the previous few lectures, you will not find this difficult at all. So first, we are unmounting the mount points of input and the output one. We have done this earlier. And now remember, the inputs and outputs are passed as data reference parameters, which are nothing but the path to the data and the data store. So we first get those data references using the widgets.get. These will then be used to build the mount point as the source. So we have the same familiar configuration key and the key value after that. Then we use these input source, conf key, as well as the access key to create the mount points for input as well as the output data. And after that, the typical training experiment begins. And we have seen even this one. So we simply read the file, create dummy variables, split them, train the classifier, as well as make the predictions on the test data. Now, just to show this experiment in two different steps, I have split the entire experiment into two. So up to this point of predictions, we are going to run it on Databricks cluster and then pass on the output datasets as well as the trained model to the next step. And that's why we create this empty directory of output1 on the blob container. And you know that as well. Now, because we need to pass the trained model to the next step, we need to import this joblib. We then write the pickle file to this directory using the joblib.dump. You have seen this also and is not a surprise to you. And because of this code, we even added the joblib as the PyPy library, which will be installed before running this notebook. So what we are trying to do here is get the data process it, train and test the outcome, and then finally give everything to the next step for evaluation. We can actually use different notebooks and different clusters to train different models and then simply send the data to the next step. Okay, I hope it is making sense. So basically what we are saying is we can have multiple notebooks and they will train different models, and evaluate will then evaluate all those models in one Python script step. So these datasets will be used for further evaluation, such as creating the confusion matrix as well as getting the accuracy score. So we need to save these three datasets of xtest, ytest as well as ypredict. So xtest will still be a data frame, but the ytest will get converted to a series when we split the original data into x and y. Also, this ypredict will be an array and not a data frame. And because of that, we first need to convert them into a pandas data frame using this pd.dataframe. Because only after that, we can apply the to_csv to write it as a CSV file. So make sure that whenever you are writing these data frames, you always convert them into a pandas data frame. Now, even if a particular variable is a data frame, it won't make much of a difference even if you use an extra line, even though it is a duplicate one. But it is again a good practice to convert them to pandas data frame before you write it using to_csv. We can avoid some silly mistakes as we go along. Alright? And I hope this is clear up to this point. And I'm sure you will now fully appreciate why we learned the parameter passing, mounting and unmounting of the blob storage, creating empty blobs or these directories, and then saving these files to them. Because now with all that learning, this script is no more alien to you. It's just a matter of putting all those blocks of code together and make them work as a pipeline script. Great. And let me now quickly go through the Python script that we will run as part of the second step. Now, there's nothing new in this script also. We have done this earlier. So we get the run context and access the workspace. Then we also get the test data parameter and join that with the file names to create the actual path. We use that path to recreate or read the data into these data frames of xtest, ytest, and ypredict. Then we also deserialize or load the trained model from this pickle file. We then get the accuracy score and the confusion from this trained model, and then finally log them to the experiment run. Great. Now with all of this covered, let's now go back to the pipeline job and run it to see what it looks like. As always, thanks for joining me here. Welcome back, and now let's see the remaining changes as well as submit this job. So here I'm importing the Python script step class, then create the step using all these parameters along with the run config that we created earlier. Then we import the experiment and the pipeline classes, create the steps, create the pipeline, and finally submit the run as part of this new experiment called DB Notebook EXP001. And now let's run this and see what we get. I am so excited to show this output to you. So select all the lines and hit Ctrl+Enter to execute it. Now when you run it for the first time, it is going to take a considerable amount of time because it is going to perform everything from the scratch. So it has to create the compute cluster in case you have not done that earlier. Then install the libraries, create the dockers and the containers, attach the Databricks cluster to the AzureML workspace, install certain libraries there also. And also because while running, it is interacting with all these different components of AzureML storage and the AzureML workspace. And very soon you will start seeing the messages that it has created the step, the data references, submitted the pipeline, and the steps are running. And within a few minutes, this will be done. And it will then start preparing for the second step. For that, it will start the Docker and container preparation. And this may take more time. So I'm going to pause the video here and come back once again when it is done. And maybe after 10 to 15 minutes, once it is done, you will see this message that it has finished running it. And if you see this message, congratulations, because that means your pipeline has run successfully. This is just awesome. So let's now go ahead and see the output in the AzureML Studio. And once you are here, simply click on Experiment. And we have our DB Notebook EXP right over here. So click on this latest run, and it will show you this completed remark, which means it is successfully completed. And wow, we can also see both these pipeline steps completed over here. Click on this link of steps to see their details. And let me first click on this evaluate step to check whether our metrics have been successfully logged or not. We can surely see the score and this object of confusion matrix, but to see them in real form, let me click on metrics. And there you go. The score as well as the confusion matrix is very well logged. Wow, this also proves that Databricks step has done its job pretty well and also successfully. And if that is the case, let's go and check that step and see what has happened with it. So come back to these steps and then click on this run ID of DB step 01. And it will provide all the details over here. So then let's also check the output and logs for this step. Then expand this logs and then the AzureML folder that you see. And click on this stdout or standard output logs. And it says it was successfully submitted, and we can view the output using this link. So copy it and paste it in a new tab. Now remember, while executing this notebook as part of the Databricks step, Databricks actually submitted a job of its own by this name that we give as the run name. So whatever happens with it is mentioned in the output of this job. So you will see the status, the task, as well as the libraries required for this job. Then you can also see the execution of each of these cells from the notebook right over here. Now, in case your Databricks step or the notebook fails for some reason, such as user error or you did some mistake while coding, you can come to this link and check what has gone wrong with it. All right. Now, the output of this step was nothing but these 3 datasets which were returned to our container. So let's go and see what has happened with it. So if you go to the storage and the container within it, you will see this new folder called Azure ML created inside it. Now, if you open it, you will see another cryptic folder. But it is not just any random cryptic code. If you go back to your pipeline steps, you will notice that it is nothing but the run ID. So what that means is, whenever we create the data folder using pipeline data, it is going to create the data inside the run folder. Whereas the data reference will refer to the direct storage that it points to. I hope this difference is clear. Then if you click on this folder name, you will see our test data folder created right over here. Click on it, and we will have all the files and this empty blob created inside it. Simply amazing, isn't it? And if you have been doing it along with me, congratulations. Let me tell you, it's not an easy task to get it right the first time. And if you search on the internet, you will see so many comments and posts where people are struggling with it. But if you have followed every lecture of this section and did all the previous hands-ons, this will be a cakewalk for you. Great. So I hope you still remember this slide where I promised you we will get this done. And I'm pretty sure now you can very well appreciate the importance of this checklist of setup, pipeline job steps, as well as listing down all these Databricks notebooks steps. Once again, congratulations on completing a pipeline using Databricks cluster. With this, you have taken a huge step in integrating the machine learning and big data using Azure ML as well as Databricks. As always, it's my pleasure to help you learn. Thank you so much for watching.